Musician. Good. Good evening. Good evening, sir. Sure. Sir, musician. Okay.
Good evening, good evening, good evening, all of you. Oh, on a does.
Good evening, sir.
Evening, sir.
Good evening, sir.
How are you doing today?
Doing fine.
You doing fine?
Yay, we see sir today.
What in did I didn't care why? Put on him Sunday best and be a thing.
What did you do tonight?
So you look totally different from what I expected.
I look totally different from who?
That's not how I expected you to look.
Same. I don't know what sir, your face not match your voice at all. Exactly. Your face not match your voice.
No, sir.
I expected you to wear glasses, sir, for some reason.
Sir, but the thing was our own man.
The nerd look. No, man, the nerd look. Me not look for. You know, the glasses and bear things.
So how you thought I would look?
Not like that.
Right, sorry, you're picking up.
I don't know why, but I thought you would be older. Have a lot of gray hairs.
Yeah, I was thinking that too.
What was that?
With some glasses on.
With glasses, exactly.
Oh,
Me stay with the glasses, sir.
I don't understand you. So you thought I wore big, thick glasses?
Yeah.
And had a nerdy look?
Yeah.
Cockroach. Like,
and a lot of gray hair, don't forget that.
You should turn on the camera.
No, say it again. Hello?
Sir, put on a shirt tonight.
Well, I am clothed tonight. Yeah, you're right. I'm clothed tonight.
Sir, I send a message.
Say, Jeremy?
I send a message. You see?
Yeah. So respond to you.
All right.
Yes, so are we ready? But I don't understand. So by my camera, you guys, Calvito.
Yes.
Come to class this early. Right.
Sir, should we put up picture?
No, but Calvito, we don't want that. We want you say one semester. No.
Camera now work.
No, it's unfair. No, you guys are cheaters. No. Turn on the camera. But Jeremy can keep the camera off, and Sean.
Somebody Jeremy and Sean.
And Arthur too.
Sir, I don't know me.
See, Arthur put up picture.
Listen to me. Turn on
so you want to turn it on for like 5 seconds and then turn it off?
No, but you guys got about a good 15 minutes look of the, what you say, gray hair and thick glasses and the nerdy look, right? But anyhow, it's always a pleasure to have my class. I was in all smiles when I saw Sash make sure she jumping on the trunk early, because Sash is the first to reach class so early.
Sir, no, sir, this is a Thursday, sir. But sir, the same tax I'm getting up. And 3 for Monday and at the back, sir. Cramp up. But me looking at trunk and I say, no, to them I have on skirt, so I can't go in that trunk.
The struggles are really, but I don't understand. I'm still waiting to start my mid semester now, right? And I don't see nobody. Charlene, Krishna, matter of fact, put on the camera. Yes, please. Yes, Sean.
Sir, when we get in the mid semester?
When you get in it?
Yes, sir.
Tonight.
All right, sir.
Okay.
Sir, the paper stressed me out.
You did?
Yes, sir.
Yes, sir. 2 other questions.
Only number 2. Only not number 2. Wait.
Number B.
B.
Sir, drink some. Sir, borrow some Ryan rum and drink when you write 2 of them questions there.
Funny enough, we talk about rum and drink. I say, what, I was going to carry something very strong to class tonight. And I said, no, can't do that because I'm on the job.
Technically, you're too much number, boss.
Mr. QC, I don't understand, you know, I don't see camera on. What is happening?
Hold on. You also, camera right now.
Sir, my son turned on my camera. I just eat one fritters a while ago.
Oh, it flitters.
Hold on there, boss.
Yes, sir. The camera turn top, but.
No, it's unfair. It's unfair. It's unfair. It's unfair.
And Charlie.
Charlene, Charlene, set you up there. I'm the
Yeah.
Charlene face you
That's
want.
that's where Kelvito, you know, you're a cheat, Kelvito.
Up, sir. You know, I see nothing more.
Yeah, you're a cheat, Kelvito. Krishna. No, Krishna, put him back to camera.
Uncle Charlene you want to see, sir. So when Charlene turn on her camera, it's done.
I don't have my camera.
We want to see Charlene.
You see? How to lead this right. Turn on the camera, Charlene. Because Charlene a pretty car eye. Ryan QC, you all right? Ryan QC microphone. Kelvito. Kelvito, you are a cheat.
Yes, sir.
You are a cheat. Turn your camera on. Turn the camera on.
Camera now work.
I hear you. Anika, I don't want to be laughing. Anika, the camera's supposed to be on. I don't understand these cheaters. Sean Anderson, turn the camera on. Jeremy, you be turning the camera on.
Sir, give everybody an extra 5 marks.
Sir, Jermaine one can stay off.
Give everybody 5% that turn on the camera, sir.
I could do that.
Thank you, Charlene.
I did so. Give him a 5.
Oh, goodness. Kelvito, I refuse to start my class if you don't have your camera on.
Sir, then it's going to be a very long night.
All right, I hear you. Yes, Sean, we know that. We know that, Sean. Yes, good. Sash ready, you know, beat up and ting, you know. Oh, goodness. I love it. I love it. I love it. I love it. All right, so clearly I'll be having class with just Charlene, Sash, and Ryan. All the others, including Kelvito.
Sir, I did turn on my camera.
What was that?
I did turn on my camera.
Krishna, you
Sir, what about me?
Utterly, absolutely. Yeah.
Krishna, you're supposed to keep your camera on.
Go through Miss Davina or Aviana, turn back the camera. With the Davina look. That's right. Love it, love it, love it. So when I see my students, I can not. Nestor?
Not feeling well, sir.
Okay, so how does that affect your camera?
Sir, I'm a little brought down. You really want to see? Yes.
Absolutely. Absolutely. I need to. All right. All right. So, you know, all you cheaters, I will just stay put with the very lovely ones who decide to stay with me tonight. Yes, Andrew, I see you. I can see your road and say, Andrew, ear up. So nice to see you, sir. Nice to see you, Anika. All right. So I really apologize. I think I disappointed some of you because you're looking for thick glasses and the whole works. But the nerdy look, I don't understand. How does one look when one is nerdy?
Sir, you're sure?
Like how Charlene look right now, sir.
Jermaine, be quiet.
Leave Charlene alone. Sash, how does one look when one is nerdy?
Nerdy girls are the best, sir.
Oh,
Here it
nerdy
is.
looking good. Okay. All right, I hear you. All right.
I try to bring out yourself, Jeremy. I try to save a suit.
All right. So what we do tonight is I gave you I gave you a mock mid-semester. Now, you're going to be honest with me tonight. You're going to be honest with me tonight. And Ryan, make sure he has his Calculus 1 book out and ready for Calculus 1, all right? Because I shall be setting a question for him.
All right, sir.
I will give him a detention. He will get detention still anyhow. So I wrote the paper, and it was written when I was half asleep, and before I sent it out, I made sure to try the solutions just to make sure that those questions can work. Because what I want you to always remember, that the questions that will come from the triple CJ would be an amalgamation of all the questions that will be set from all the other community colleges. So I want to make sure that you guys are fully ready for what is to come. I don't want any surprises. And as I said before, just look at the conceptions. I teach by concepts, and once you can see the concepts, you are good to go. You are, when I say good to go, I mean you are good to go. All right. So let me see if there's any other. If there's any other that okay, Sean, I see you, and your Kelvita is not playing fair, and I'm just not going to play with Kelvita anymore, because Kelvita is just not.
I love you too, sir.
I love you even more, Kelvita. All right. So what I'm going to do is I'm going to be sharing. That may interfere somewhat with the nerdy look, because it may go. Question though, before I start sharing, how were you able to? Okay, so I need to hear, the how it is that the questions were, the difficulty level, etc., etc. I need to hear what is happening. Talk to me. How was the paper?
It wasn't bad, sir. Only B.
Only part B?
B and the last question for part C, sir.
Boy, I'm not
fraction.
I'm not really sure about that still, but maybe attempt it. B, definitely B.
Okay.
Sorry, I never fully went through the fraction question the other night, so I don't think we actually got
the first principles.
Yes, sir.
It's our example though in the.
And no problem. That's not a problem at all. I'd be more than happy to do the review on the first principles using the fractional form.
I got you everything right, sir?
Absolutely.
I go wrong.
Absolutely. But only when you turn the camera on.
Sorry, you know I'm looking already.
I did a little shortcut, so I don't know if I'm gonna lose marks.
5 seconds, Jermaine. 5 seconds.
Stop you. Can't ask.
Remember that's why, man. I know some annual already, but I beat long time.
So you're saying to me then that this is it? Nobody else is going to turn on? All right. Well, eventually you have to, because
I can get pictures in the sir if you want to.
Say it again.
There's some picture up there work, sir. So.
Sir, when I ask you the question, you turn it on.
Okay, all right, no problem. Fair enough. All right. So what is going to be important is that for the mid semester come next week, before I do that, before I even go through the mid semester, there's some housekeeping that I need to talk to you about, and to get your feedback on something. Question. Let me ask you a question. And to be honest with you, I am very pleased for the kind of comments coming from students in the group. It really says to me that you are appreciative of the efforts that I'm making just to make sure that you guys get what it is that you're supposed to be getting. And I'm going to tell you, well, I thank you for that. But one or two of you accuse me of not sleeping, and it is the truth. It is the truth, because when I finish a class, I often sit and reflect, how could I have made this class better? What about those students who were not answering? Are they understanding? So, I do a lot of self-evaluation, and I was even in more smiles when I read Sash message. Yes, sir, turn on him camera tonight. You know, it lends itself for the sort of suspense, you know, for class tonight. And I mean, I'm excited to see Andrew and Arthurline and Charlene and Ryan and the whole of you, you know. So it brings for me the sort of relationship that we have for this course. And today I was saying to myself, you know, Lord, what would be really very nice if all these students can just do what it is that is required of them, and you know, they will all pass the course. If all of you pass the course without a shadow of a doubt, I come back for calculus 2. All of you pass the course. So it means now that everybody has to hold everybody else accountable. All right. But you know, the kind gestures that I have been getting, you know, things like these cause me, when I feel like I'm at my wit's end, cause me to say, let me serve another year, and then the other year turns 5 more years. And you know, it is really, really, really a true feeling. When I look at people like Jermaine, I remember when Jermaine just started, and now is in 3rd year, looking forward to his final year. When I look at people like Sean, and you know, it says to me that what it is that I'm doing is appreciated. Good evening, Yanyan, is appreciated, and I will continue working. And you know, I'm hoping that the amount of energy that I put into my whole delivery will be appreciated to the point where you guys, you know, get what it is that I'm trying to say and really make me very proud. That's all I'm asking. I just really want students to be very successful in what it is that they do. Which brings me to my final question before we start working the paper. Out of the online experience, okay, and my question to you is not based on, and I like that positive talk, Ryan. I love it. My question to you is not based on the all right. I'm going to speak specifically about calculus 1. No, let me not do that. Let me do it as a 2-part question. So, how many of you so far prefer the online medium versus the face-to-face medium? So I'm seeing, so those hands that are raised suggesting that you prefer the online medium, right?
Without a shadow of a doubt, sir.
All right, and I hear you, and I'm seeing it. I'm seeing them. Very good. I'm seeing them. I need to get a response from the others. So
Sir,
trying to assume. Say that again.
No, I'm not like, sir, you're just very skilled when it comes to word typing all that. I don't know you do it.
Yeah. Matter of fact, I had a student in pre-calculus about 3 semesters ago to say, "My goodness, sir, oh, you operate the system so quickly." You know, it is what I have to do since I've used this medium not to write. I mean, I have my writing tablet. I have my writing tablet here that I can write, but I choose not to because I really want you guys to have the soft copy of what it is. So yes, I make it a point of my duty to understand my software that I'm using and Microsoft Word, and you know, do what it is that I must, because you know, I don't take what I do for lightly. But going back though, I'm seeing Jermaine. Andrew, you had your hand up. Charlene, I don't remember seeing your hand up. Is it that you prefer the face-to-face? You'd rather go face-to-face?
Sir, a little of both. In terms of, for me, the only issue I have with face-to-face is when I'm to leave school. It's very lonely where I live and I don't drive. So I would have to walk on a lonely road to get home. But other than that, I prefer face-to-face, sir.
All right. So for now then, the online medium is fulfilling, you know, what it is supposed to fulfill for you.
Yes.
Yes, it is, because it takes some time to. Well, I am assuming that for most persons here, the hassle from leaving work at a certain time to reach school on time, it's going to be a bit hassling. Well, for me.
Okay, got you.
That part
And
of it is not really an issue for me because I live both close to work and home, so it's
You know, so that
about the
varies
same.
between persons as well. So
No,
Yeah,
no, it's not from work. No, I'm not saying that from work to home. I'm saying from
No,
work to school.
I live close to school and work.
Oh, okay, that's good for you then. That's
Yeah.
nice.
Yeah, but if you live close to school and work, I may have an idea where is home. And yes, it can, Sash, behave yourself. Anika, tell her to leave you alone, no? Sure. Yeah, I really wouldn't want, anything to happen to you having, recognizing that you have to travel on a lonely road. And I hear Ryan says it's not a matter of preferring the online medium, but it is really very convenient.
yes, there's a convenience.
It's a convenience. Let me tell you why I asked the question. I asked the question because I don't know how many of you have been listening to the media. And I know yesterday came over on the news, where there are some interest groups are asking for the immediate return to face-to-face. And I'm saying, I have my own thoughts. I have my own views.
Sir.
Huh?
Name now cope with the online thing.
I don't. No, but okay, put yourself in
maybe college students are we maybe can cope just easier. But I guess maybe the primary school and the high school students are
then internet.
Yeah. Plus persons without internet access
as well.
Right. And they can access the area and the primary school transcripts. They can realize not work at all.
Yeah, I recognize that. And one of the things I was saying to my assistant today is I'm wondering if it is how the teachers are presenting their lessons, why students are disinterested in what is being done. And which is why I said I didn't want to selfishly talk about Calculus 1 now, because to be honest with you, I'm not selling an idea to you, but the truth is I don't know if there would be a difference if I were to go face to face. Krishna, I don't know if there's going to be a difference if I were to go face to face or continue online, because it makes, I think the same thing you get from me online is going to be the same. The only thing that is going to be different really is seeing me in person. And if you see me in person, you say, but I'm a little bit, right? Because I don't press 250 pounds like Andrew and Jermaine, right? So, when I stand beside Andrew and Jermaine, I look like a 5-year-old compared to them big giants. But the truth is, I am aware, I understand that there are quite a number of students that are disengaged using the online medium, and I'm very disappointed with how should I say it? The private sector. There are so many times you hear, oh, we donated 42 tablets to this school or 150 tablets to this school. They don't want tablet alone, they want internet access to. Them can't go online class without internet. So get some money and set to the internet providers. We are going to provide hotspots within these areas so that people who, in particular, and don't get me wrong, people who live up Jackson and Barbican will have Wi-Fi. Go into the inner city communities where the students have to go to school and put up different devices so that the students can connect to their hotspots. Or say to the students, once you go on Zoom or Google Classroom or Educasoft or any online learning device, you don't pay for internet access. You can access those free. I quite frankly believe that Jamaica has failed the education system as it relates to the whole business of the online teaching and learning. That's just my personal view. And it's just unfortunate. There are times, right now I have 2 devices on. Should in case one goes, it is not your responsibility that, oh, sir, is gone. I must be there. And if it is that my internet is unstable, I have to grab for the phone and I have to stream my class using my data because it is not your responsibility why I'm not there. And I don't know, but I take this thing. This is my job. This is my livelihood. You know, I've been teaching for quite a number of years, and this is just who I am. But I think others may not, you know, take, you know, this thing. It's funny. Go ahead. Somebody has a all right. So somebody has a question. So you can lower your hand. I kind of hear you guys. I'm not sure if that last raised hand is a question that needs to understand. Thanks, Jermaine. You know, I do what I need to do. I do what I need to do. All right. So with that said, I am going to go through these things here slowly. The questions that I'm going to be doing now, and what I want you guys to do for me is to be honest with yourselves, to be honest with me, to be honest with your classmates, because we are going to be accountable to each other. That if it is that you didn't get the question and I asked, just verbalize for me where it is that you went wrong, what it is that you're not understanding, because this will only make you guys very, you know, very successful in the mid semester next week this time. One of the things we're going to be doing today is we're going to be looking at an orientation for our online exams. As I said before, I'm one who operate a little differently from the others, and I love my students, and I say to my students, you know, this sort of relationship that we share is going to be one of honesty. And when I give you work, I expect the work to be done by you. I have gone through the length and breadth from we would have entered into COVID to create a YouTube channel. And if you look into the channel, you see multiple, you know, videos inside here. One of the things that I wasn't doing, and I've started doing it since I've started this class, is to look at the is to title the video. So at least, you know, if it is that you're having a challenge with integration with a particular area, you can let me know. You can let me know what it is, and I can look at it and say to you that, you know, this is going to be a video on differentiation or a video on integration, so you can pinpoint the videos as opposed to wasting that we do what it is that we need to do. But importantly, I want you guys to be very honest with me, honest with yourself. There's a God that looks down at what it is that we're doing. I know everybody wants to be successful, but you have to put the work in. You can't just depend on unscrupulous beings, you know, or the attitudes inside of us. You know, inside of us, we have that sort of sinful nature that will cause us to want to do things that we're not supposed to be doing. So I say this to say to you on the background that I trust you. We've been having an honest, really want to be disappointed. And I'm going to tell you straight up, the teacher has a way of knowing whether or not there is collaboration when a test is given. And we know. I won't tell you how, you know, we all went to teacher school, and we have ways. I mean, it's math that I teach, and when I'm teaching other subject areas, I have ways of recognizing when students are collaborating with stuff. So I really want to know from this exercise tonight.
What subject you teach, sir?
Say it again, Pops.
What other subject you teach?
Well, I'm just gonna ask a question, you know.
Or chemistry.
Chemistry. Okay.
Mm-hmm. So I mean, chemistry, yeah, generally. So last semester I taught environmental chemistry and engineering, environmental engineering. So yeah, I'm a science-based person, so I do.
Not physics.
No, I don't. Did physics, but I don't teach. I leave it for the right people. All right. So you know, I really want honesty, 100% honesty, and I really want to know, especially tonight, those areas that you are having a challenge with, so that I'm better able to deal with those challenges tonight. I'm going to put aside, no, you are getting an A. I'm going to put aside quite a bit of time tonight.
That meant question B.
Oh, okay. I'm gonna put aside tonight quite a bit of time to go through these questions. Whatever time that is left, I will, go back through some differentiation because I can't leave with differentiation just yet. Even though I would have taught you all the rules on the differentiation now, I still have to give you some other areas to sharpen those skills. So what I'm going to
one, sir.
say it again.
No, I appreciate you going back over the differentiation.
Yeah, man, I have to. I can't take it for granted. All right. So you are seeing my screen, and the first question says, evaluate the following limits. And this one says the limit as x tends to 5 of x squared minus 2x minus 15 over x minus 5. Now, can somebody just verbalize for me what's the first thing to do?
You substitute.
Factorize the
No, the first thing is
substitute
first.
Yeah,
right.
Find out if it's an indeterminate or a determinate.
Equate x to 5.
Very good.
spoiler alert.
So, very good. So when you substitute, what do you recognize?
It's an indeterminate.
That is of the indeterminate
Indeterminate.
form. Very good. So that's the first thing, because if when you substitute, you're not getting indeterminate, it means that whatever result that you would have gotten there would have been the answer for the question. Fair enough?
Yes, sir.
Wait,
Okay,
sir.
good.
Hold on.
Go ahead.
So you could have found out that it's indeterminate just like that?
Absolutely. By
Oh,
substituting.
get a
5
zero.
squared is 25, minus 2 times 5 is 10. 25 minus 10 is going to be positive 15, and positive 15 minus 15 is 0. And then 5 minus 5 is 0. So you have 0 over 0. So it's indeterminate.
That's what I mean. That's what I mean when I get the answer. I was okay.
Yeah, man. Yeah. So that's going to be indeterminate. So you know when it's indeterminate is one of 3 things that we do: simplify, rationalize, or factorize. Now, when I look in the numerator, I recognize that it's a quadratic. Chances are I can factorize. Now, when it's indeterminate, remember what Sir said. When it's indeterminate, it simply means that there is something inside of that fraction that is causing the limit, the true limit of the function to come out. So there's something inside of that fraction that is causing the true limit of the function to come out. Now, when you look at it, one of the things that I can, matter of fact, can somebody hazard a guess what is causing the true limit of that fraction from not coming out? What term?
The denominator, sir.
Excellent. It has to be the denominator, because whatever we do, we will still have the denominator in the question. And if x is tending to 5, 5 minus 5 is going to always be 0. So I can look at the question and I can say that x minus 5 is what is preventing the true limit of the function to come out. So I know that there's an x minus 5 in the numerator that I must cancel out. That's one of the ways of looking at it. I know that there's an x minus 5 in the numerator that I must get rid of, because that is what is preventing, sometimes I have some people in your lives that you can't see your true potential because them are hold it down. Yeah, man, you have to get rid of them. And friends that is, get rid of them, because they may be pulling you down, so you're not seeing your true potential. That's exactly what is happening. So let us go to question number 1. So you will see for question number 1, what it is that I have there. I will have to factorize my numerator. And factorizing my numerator, I recognize that, and you notice what I did? I did not show you the factorization of the x squared minus 2x plus minus 15, because I expect now at this stage that you will know. Yes, please.
I was going to ask if I could skip all of that. Thanks.
Great. You know how many marks for this? 1, 2, 3. So I don't expect, at this point, I expect all of you to be able to factorize by inspection.
Because I was looking at the exam question and I was like, I'm not doing all of that.
No, negative. I ain't doing it either. I only showed you, because I'm teaching you and I really want you to understand what it is that we're doing. So look at what I did. I jumped from here to here. I want to tell you something, but I am afraid of doing it because.
So question, sir, before we move on.
Yeah. Yes, good.
You're thinking there right now. The first
I'm sorry, Jermaine. I'm not seeing your face. So I don't know.
I said your thing.
I'm not seeing your face, Jermaine, so I don't know. Jermaine, I'm sorry, I can't hear you. Can anybody hear Jermaine? We need to see the camera so we can see your lips moving, Jermaine. Sorry.
Awesome, make your ears, I'm deaf.
You're deaf. You know, Sean,
I play by yourself.
Jermaine, 5 seconds, Jermaine.
But they are what in me, they are working, I understand. Charlie.
Yeah, whatever, Jermaine. Yeah, we all know how you look. So go ahead, Jermaine.
Exactly, so you know, look already, I'm most impressed with my classmate. Anyway, if we not have the because see the x minus 5 in the first part is a 1 mark.
Yeah.
You know, I put that there so I can put it down below. When I lose 1 mark here, so.
You need to put the x minus 5 here. So you didn't, this one here, you didn't put that?
Yeah, just put the top part and then just and then go down to the next part and put the x minus 5.
And then go down to this part here?
Yeah.
No, man. Yeah, you have to show the working. Yeah.
No, the working did here, sir. But my working look at this exactly. Have the that part here. The first part here circle is more complex.
So Jermaine, you basically did show the factorizing.
Yeah, we show the factorizing and then we get a factorizing now, then we move to the second part.
Yeah, same.
And that's fine. And that's fine. And that's fine. So if you show me the factorization, it's neither here nor there. You won't get any extra marks. But if you want to be on the safe side, sure. So what Krishna is saying is that he never did that because he was already sure that it's going to be x plus 3 times x minus 5. That's fine. If you want to show it, I won't kill you. No, man, I won't kill you. But
so you can necessarily could have done it like that?
Absolutely. But remember, you know, what I was doing before, you know, Sash, was to present the material in such a way that I don't skip any steps so that when you're going through, you can actually see what I was doing. Now it is that we're moving from breast milk to start eating mashed potato, and then now we're going to start eating yam and banana.
To be honest, sir, when I looked at that, it kind of confused me.
Okay, and that's fine. And that's fine.
But
that's fine.
Sir,
go ahead.
Do you not show the substitution and then show the factorization?
Absolutely. So absolutely. So what I should have here, and you know, the truth of the matter is, I did this before I sent off the stuff. I had to do the what do you call it, the solution, so that I make sure that it is correct.
So sorry, you don't upload in the exam, you don't upload the substitution to show the indeterminate, right? You can just move straight down.
No, that's what I'm saying. You have to show that it's indeterminate. So I am agreeing with what Kelvita just asked.
4 marks and that is then. And a 3 again.
Yeah, you can't expect to do all that for just 3 marks.
Because I'm going to show you the indeterminate, so it's get like a mark for that too.
And I'm saying to you, no, you're not getting no more. But oopsie daisy, you're not getting 1 more mark for it. Guess what? You must show that this is indeterminate. You must show that it's indeterminate so that you can move on to the next step. Because if it is not indeterminate, if you assume that it's indeterminate and it's not indeterminate, we can get the question wrong.
You know, I understand the part then, sir. I understand the part and say, all right. So me do a quick calculation where that says indeterminate or whatever. But I'm gonna show it or we get to let's move on. Instead I get the 3 marks and
I'm saying to you, Jermaine, put equals 0 over 0 indeterminate. Let me know that it's indeterminate.
Oh, okay. All right.
You have to. If you don't, you're gonna get into some serious problems.
All right.
All right. So you have to do it. You have to show. All right. All right. So so you have to show that it's indeterminate. You must show that it's indeterminate. All right. So what was going to happen now? So having looked at this stuff and we've seen that it's of the indeterminate form, what it is that we're going to be doing next is to say to you that what is preventing the function from showing the actual what is preventing the function from showing the actual limit. Something in the function is preventing the actual limit from coming out. Something in the function is preventing the actual limit from coming out. Now I need to deal with that function. I need to deal with the function, find out exactly what is preventing the true limit of the function in coming out. So look at what is going to happen. When I do my factorization, I'm going to be getting x plus 3 times x minus 5. And x plus 3 times x minus 5 will give me all of this up here because I've done my factorization. All right. Now, for the answer here, why you didn't see me put the 0 over 0 and the indeterminate, because I was expecting, you never normally get a mark to show them that it's indeterminate, right? So if I were teaching you, I would have my indeterminate and my 0 over 0, then I would say no factorize, because what I'm trying to do when I'm teaching is to show you what exactly I'm doing so that you can follow stepwise. Now, at this stage where we're doing the mid-semester mock, I would expect that you know that this next stage is going to be your factorization. From here to here is going to be your factorization. And the next step is to isolate or to cancel out those areas or the terms that are preventing the true limit from coming out. And what is preventing the true limit from coming out is this x minus 5. The x minus 5 is what is preventing the true limit from coming out. So when I cancel those, I'm left now with the limit as x tends to 5 of x plus 3. Now it is that I can go ahead and resubstitute that x plus 3 into the function. And when I substitute x plus 3, I'm going to have 5 plus 3 is equals to 8. So my answer here is going to be 8. Now, my question to you, did all of you get 8 for your answer for number 1?
Yes, sir.
Yes,
Very
sir.
good.
Yes, sir.
Very good. Andrew,
Yeah, yes, sir. Yeah, man, I'm
Very
good, man. Good.
Very nice. Ryan, how you stay?
Yes, sir, I got that one.
Yes, sir.
Very nice. Aviana, how you stay? You got it?
Yes, sir, I got it.
Very nice. Kelvito?
Yes, sir, I got it.
Nice. All right. There's a new student. I just passed a new student. It's not Henroy. What is Henoy?
Sir, it's Davia, sir.
Oh, that's Davia?
Yes, sir. I'm using my brother's laptop.
Oh, you called him your brother now?
I didn't realize it was his name, sir.
Okay, yeah, so he's your brother now.
What do you mean? I want last name of Barnwit, sir.
I'm troubling you. All right. Okay, yeah. So you need to. There is supposed to be, I think, no, sorry, that's my CAPE class. Forgive me. It's my CAPE class. I'm a student told me that they need to. Okay, fair enough. All right. All right. Great. All right. So, Jermaine, this one is for you. I know how you're staying at Jermaine, and you're one of those students who will say to me, "Oh, sir, but I did skip out this line, but I got 8 as my answer. If I don't see the steps, I'm not going to get the mark." So I don't want anybody to shortcut, because to calculate the limit of a function is really not difficult. And I know quickly and easily you can look at the function. You know that bam, 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 that. And you don't show that it's indeterminate, and you can cancel this and say, sure, x minus 5 going to skip out. You're not going to get the mark because I'm not seeing it. There are several steps, critical steps in the question that you are going to be given the mark. This indeterminate, you're not getting a mark for that. But guess what? To do the factorization, I'm seeing that you know that this is indeterminate, so you're getting the mark for the factorization. To isolate what is happening, you're getting the mark for that. And then to correctly substitute. So I could give you 4 marks because I could give you another mark, correctly substitute this x equals 5 into the function, and then 1 mark for the x equals 8. But for the convenience of what has happened, it's 3 marks. So very good. I'm happy that you got that. Is there anyone in the class who did not get A for your answer? I want you to just be very honest and just talk to me so that I can do some corrective measures before Thursday. Are we all okay?
Sir,
Sean, say it again.
With me, I was having challenges with the sign.
What signs?
Right, the minus, the negative, and the positive.
For which ones? Oh, for the factorization part.
Yes, sir.
All right, guess what, Stash?
But I still end up getting, I fix it and get the answer.
Yeah, but guess what, Stash? It's one of the things that I'm going to ask you to work on, because it's not the first time you have said to me in class that the factorization is giving you problems. So, and this is, and it comes back to my point. It's neither here nor there for me, online or face-to-face. And this is why I encourage my students to speak so that I can know exactly what is happening. Because And it's not the first time you hear me saying that to you, right, Sash?
Yes, sir.
Right. So, I know where it is that you're having a challenge, and I really am going to be encouraging the rest of you to speak to me so that I can, be saying to you, work on that. So you have a week, Sash, to just practice your factorization to make sure that your factorization is on point. All right. Is there anybody else that had a challenge before I move on?
No, sir, it's not a challenge. Just for clarification. So what you're saying, if I don't show line 2 different from line 3, I'm going to lose a mark.
What I want to see is a factorized form. However you show it, I must see that you have factorizing x plus 3 times x minus 5. I will also need to see that you have isolated this, that you are taking out what is causing the problem for the question. And I'm also seeing that you have done, you are left with this x plus 3, and then you are going now to do that substitution. So those are the 3 critical steps in this question. As I said before, I could give you a 4th mark. And that 4th mark could be having this, and then I give you that mark, of course, for the answer equals 8, right? But sometimes you go, because this is really not a difficult question, you're going to the exam and sometimes they may even give you 2 marks because this is really not difficult. I agree with you that part B is something that you have to think about. And I know many of you, as a Charlene Facebook, please, sir, just get to part B, because part A was nice. But
Sure.
we will get there. All right.
Sir, me will leave the page blank for part B.
All right, let's go. So number 2, I don't want to go any further. I don't want to go up any further with number 2 because I want to hear from you now. So you're given a question where x is tending to infinity. X is tending to infinity. What's the first step?
Find
the indeterminate.
Highest power, sir.
Hold on.
Is it?
I heard somebody say indeterminate. Let me just correct. Is it indeterminate we're looking for?
No, sir. Just make it equal to.
Very good. So remember, the only time we're looking for indeterminate is when x is tending to a number.
A number.
Right. And you have a fractional form. So if you're given a polynomial, say x squared, the limit as x tends to 5 of x squared plus 2x minus 15. Well, we know that is going to be equal to 0. But they can give it a question. The limit is going to be 0. You don't have to worry about indeterminate because indeterminate is only when you have a fraction where both numerator and denominator is equal to 0. So hold on. So I have been doing my preparations for you guys. And as I said to you, I can't do for you, well, I can do it now because I show you how to differentiate. L'Hopital's rule. I'm going to explain why L'Hopital's rule becomes very important. I want to show you an example now because I really want you to be able to master the differentiation because I have to use differentiation for L'Hopital's rule. And I really want you to master the differentiation so that when I give you the stuff, you can really understand. And when I give you the explanation behind it, you can say, yes, sir, it's true. But let me just talk to you about this one here. You see the 0 over 0? Something in it. 0 in the numerator and 0 in the denominator. The answer is equal to 0, sir. No, something is off. There's something inside there that is preventing it. It's obscuring the true limit. And this x minus 5 you recognize is in the denominator, and you can't have a 0 existing in the denominator. So because you can't have a 0 existing in the denominator, it therefore becomes this portion that must be isolated. Now, when we move to the infinity, either positive infinity or negative infinity, we don't talk about indeterminate form. But sir, you have a fraction, and so we don't talk about indeterminate form. What we talk about is looking at the highest power in both numerator and denominator. So we look for this and we recognize x to the 5th is the highest power in the numerator, and we look and we see that x to the 5th is also the highest power in the denominator. So we are going to be dividing both numerator, each term in the numerator, and each term in the denominator by x to the 5th. True or false?
True, sir.
All right. So that's exactly what it is that I do. And to recognize that that's what must be done, you're going to get a mark for that. So I remember I did say to you that I want you to be honest, So wherever I have the marks and the explanation I'm needed, if you don't see it on your paper, don't put the mark there, Right? I really want you to be honest.
Yeah.
Because this is going to help you for the actual mid semester. All right. So what I'm doing, and then of course I would want you to tell me, you don't have to broadcast it, but you can send me direct messages as to how much you scored yourself out of the 30. And I really want you to be honest. I trust you. And if there's ever chance that you do something that I can't trust, that you break the covenant. All right,
so next question, sir.
Yes, Papa.
So what I'm gonna do is instead of x5, x to the power of 5, x to the power of 5, x to the power of 5 must have 1, 9, and x to the power of 5.
No.
I still the denominator, sir.
No.
We still work with the same thing.
I don't care. Each term, Jermaine, must have its own to do its own calculation.
I understand.
Okay, Jermaine, you can put it there. You're not.
I go to this again, sir.
You're not getting this smart, Jermaine. You can't. Let me tell you why I don't want you to do it like that, Jermaine. And the rest of you can agree with me. You see, when you put everything under here and put it over x to the 5th, when you're canceling out this one, I am not going to see what exactly this 2x cubed is going to be sitting on to get me now to say that it is sitting on x squared.
Sir, they said it's a big school maths, sir.
Okay, all right. Okay.
I'm just saying.
I'm hearing you. But I'm also saying,
Jermaine, you can't win, Jermaine.
I am also saying, Jermaine, I need to see this. So when you cancel out your x cube into your x to the 5th, I'm seeing this term. I'm going to tell you why. It makes a lot of sense for you to isolate them. And again, I'm dividing.
Isolate them, no, sir. Isolate them, no, because so if I'm doing it up here, so I'm coming to the next step. Actually, show it like this.
You show it like this?
Yeah.
Right,
so even though I have it under 5, like x to the 5th, just like if I do like whatever, when I find the lowest common factor, I just have 1, whatever. I set them over, but we the next part actually break it down like this.
Okay.
It is for me, so my brain did away there.
Got
so I ask them to lose the mark for that.
Okay, so what I want you to do, see because your brain work like that, write it how your brain work on paper, on a different paper, and then put it like this on my paper.
All right, so you win.
Bless you. Bless you. Bless you. Bless you.
But
all right.
The cross.
Show the cross, show the cross.
Yeah, we should show the cross note because I'm gonna try to figure out when we get wrong.
You want me to show you how I cancel it out?
Which one you cross out? Which one?
Yeah, that's what I'm going to do. Come on, I don't reach here yet. I don't reach here, Krishna. So what I'm doing here now is I have 2x cubed over x to the 5th. So this x cube, all of this x cube will cancel out with 3 of the cubes in here and leave square.
Oh, that
so I'm going to have 2 over x squared. And then the x to the 5th cancels with all of the x to the 5th. Remember the law that I showed you? A to the m over a to the n is going to be equal to a to the m minus n. I'm subtracting the powers. So it's going to be 3 minus 5 is minus 2. And I don't want a minus 2 in the numerator, so I put it in the denominator, it becomes positive 2.
Sir, question.
Yes,
6x over 5 to the 5th.
X to the 5th.
Sir, so 6x is not going to cancel out there, so.
No, there's no 6 in this denominator to cancel. So the only thing can cancel is a variable. So I'm taking out what, remember this? Okay, let's go back again.
Hold on.
So,
because no, don't take it out, sir. It's because I see. Oh, my bad, sir.
Oh, okay.
Because yeah.
Okay. So this is what is that. Go ahead.
Yeah, before you proceed, can you repeat the rule when x tends to infinity?
Oh, so I'm just saying to you, when x tends to infinity, we can't talk about indeterminate form. When x tends to infinity, we don't refer to the indeterminate form. What we refer to is looking in the numerator and the denominator, the one that is raised to the highest power, and divide through by those.
Sir, so what if you put infinity over infinity and say indeterminate? Would I?
And that's fine. And that's fine.
That is what I was saying, sir.
Oh, sorry. Yeah, man. Because really and truly, when you look at this, this is really indeterminate, This is really indeterminate. And that's why we're doing this sort of something. All right. So let me backtrack then. All right. So what I want you to do then, since what I want you to do is, all right, let me see if I can. All right. So now you know that it's indeterminate. And because of that, and you would agree with me that everything in the numerator here goes to infinity, as well as everything here in the denominator goes to infinity. All right. You recognize again that x to the fifth goes to infinity faster than the other terms. We have done an example to show you why it goes to infinity faster. I also showed you that in this case, x to the fifth again goes faster. So you will say to me, but sir, wouldn't this be negative infinity then? Absolutely. And would this one be negative infinity? Absolutely. But when you divide negative infinity by negative infinity, you'll have positive infinity over positive infinity. When you divide two negative numbers, you're going to get a positive number. All right. So yes, so you're correct. It is really indeterminate. We established that from before, that it's indeterminate. But when you recognize now that it is indeterminate, you can't find out exactly what the limit goes to. It's similar to the question we did before. We have to now go and investigate further. What is the investigation further, sir? We're doing a factorization, a rationalization, or a simplification. What we're actually doing, we are simplifying the function here. We're doing a simplification of the function here. So it is that we can remove those terms that will tend to zero. By doing that, we are dividing through by the highest power in not just the numerator and the highest power in the denominator. We are looking for the highest power that is common to the numerator and the denominator. Let me say that again. Very important. I'm looking at the highest power common to both numerator and denominator. So if I had an x to the fifth in the numerator and an x to the sixth in the denominator, I won't just divide the numerator by x to the fifth and then go ahead and divide the denominator by x to the sixth. I am dividing through by the highest power. So it means that even though there is no x to the sixth power in the numerator, but there is one in the denominator, all are up here, so we're divided by x to the sixth, because I'm dividing through by the highest power, not in the numerator, but in a full function itself. All right, so with that said, come Krishna. So x cubed over x to the fifth, remember, x to the fifth is saying that I have x multiplied by itself 5 times. And x to the third is saying that I have x multiplied by 5 times. All right?
Yes, I did that wrong.
Again?
I did that wrong.
Okay, and I love your honesty. So what is happening is all of the 3 x's that are being multiplied in the numerator will be cancelled to 3 x's in the denominator, and I'm going to have 2 of the x's left. And that's why I have 2 over x squared. X to the fifth can cancel x to the fifth, so I'm left with -4. Similarly, I have just 1 x in the numerator, but I have x being multiplied by itself in the denominator 5 times. And when I take out one of the x's from the numerator here with one of the x's in the denominator, I am going to be left with 4 x's in the denominator. 4 x's I'm going to be left with in the denominator. So this is why it's going to be 6 over x to the 4th power. Similarly, this one goes with this one, so I won't go back to that. So this is going to be 1 over x squared. This one here is x squared. It means that I have 2 x's in the numerator being multiplied by all of 5 different x's in the denominator. 2 of these x's will go, and I take off 2 in the denominator, so I'm going to be left with 3 x's. So it's going to be x cubed, see it right here. And this x to the fifth cancels with this x to the fifth. Now, what is important? What is very important is this my statement. As x tends to infinity, the fractional form where you have a constant in the numerator and a variable in the denominator, all of those, this one, and this one will all tend to 0. I don't need to prove this to you again. You don't need to prove it to me because we already proved that in class. All right?
Sir.
And then, go ahead.
Hey, look, I'm get the answer low. I got the answer right.
You got the answer right, but the working out part was incorrect.
Yes, sir.
Fair enough. Love your honesty. All right. So what you'll do, you'll get the mark for the answer, but wherever you didn't have it, just subtract the mark from that, and then I want to get a true reflection as to what it is that you would have gotten had this been the correct thing.
The crossing out part is just 1 mark, right?
Yeah. But I need to see this for you to tell me that, because you can't just move from here to here without telling me why you're moving from here to there. So I need to see this. Right. I need to see this portion. So you see, you can get the question right, and instead of getting 4 out of 4, you can get only 1 out of 4 because none of what it is that is showing me here, you just jump to the answer. All right, watch me now. So having X step, go ahead, please.
If I have the X over X squared, that's fine still? Or it has to be 1 over X squared?
It has to be 1 over X squared. It has to be 1 over X squared. Because the numerator has to be constant in order for it to go to 0. The numerator has to be a constant. It can't be a variable. You know why? Because if a variable is up there, it is going to take a longer time for it to go to 0. So it has to be a constant. So just make sure that when you look at this stuff here, all of these up here are constants. They must be constants before you can go ahead and do this stuff. It's very important.
A little.
Go ahead.
Scroll up a little.
Scroll up a little. Yeah.
Okay, so I'll get marks for working out that part.
For this part here?
Yes.
All right, good job, good job. All right, so what I'm doing now, I'm doing my substitution. I'm saying this portion is going to be 0, all my fractional forms will be 0, so I'm left with -2 over -4. I'm left with -4 rather over -2, and that is going to be equal to 2, and that's my answer. Question? Now hear me out. Anybody who goes into my exam next week and gets any of the limits question wrong, I will charge you. And any amount of charge, Andrew will pay double the amount. So please, yes, Andrew, you can pay double the amount. Double the amount.
Oh yeah, the answer so bad.
No, because we expect Andrew to get 1 A. And the rest of them to may expect to get an A. No, listen to me, man. You see, next week when me drop my test, me knows that me must have something very nice to eat thereafter because me know me now be able to sleep. Come, I have to go sit up for them papers there. Don't let me speak in tongues because me know she never call on. If I 1 o'clock, 2 o'clock, the phone I go ring and make up here nice if you don't fail my test. All right? All right, let's go. You bet.
But for a nice party as well.
And if you tell you, man, listen to me, man. Man, have some good yamins and all.
What's the pass mark, sir?
What? Is it? Pass mark? 99.5%. All right, let's go. Let's go. All right. Sash.
Sir.
Ramp with me, Don't play with me. No, Mr. Mwan, make sure you say pass or something, Chedi. Don't play with me, Aviana, don't play with me, Miss Smith.
Sir,
Lambert.
I got it right. Right.
Nice. Lambert, can you turn on the camera for me, please? Is it in? Is it all these cheaters? Yanni.
1 second, please.
Okay.
Sir, may they turn on the camera?
No, no one to say. I said you not on speaking terms tonight.
Sir, I turned on my camera.
I'm not on speaking terms with you because I didn't see you.
Oh, but everybody else see me. I turned on my
She did turn it on, sir.
Oh, okay.
Did you turn it on?
I want to see you too.
Is it in? And
1 second, please.
1 second. All right. Is it, go and get close, please. Yannick.
Sir, I have a question.
Yes, please.
First, the limit question that we got, that's the hardest one we could get.
Say it again, Pops.
The limit question that we got, the first one, that would be the hardest one we could possibly get.
You see, there there are several types of the limits question. And I mean, I really appreciate the question. I didn't specify what I'm going to specify now, but for the limits, you can get, well, I did specify. You can get a polynomial, which is just a straight function like x squared plus 5x plus 6. And they ask you to find the limit. You know, those types of limit questions are always continuous because you don't have any points of discontinuity. So what do you mean? There's no restriction to it. The only questions that you can get points of discontinuity are those that are fractional. Why, sir? Because it means that the denominator can never ever be equal to 0. All right. So outside of that, any other function that you get will always be continuous. The only ones that you will have points of discontinuity are those that are going to be in a rational form. What do you mean by rational form, sir? The fractional form. All right. So Krishna, you can have one where you have a polynomial. You can have one where the highest power is in the numerator. So when you get the function, the limit tending to 0, you can get the limit to be 0, or you can get the limit to going to infinity or undefined. All right. So, and those, of course, you can get when you find the limit to be equal to a number like what it is that we're doing. So there are generally about 4 different types. I would have given you all the different types in the lessons before. All right. So you just look at what it is that is being asked of you, and you should be good to go. You should be good to go. Yeah, man. So it's not necessarily the most difficult part of it. Really and truly, if you understand the limits, it's really not difficult. You know, once it is that you speak about a fractional one, whenever you get a limit of a fractional form, always check for the function to be indeterminate. If you get it to be infinity, you know that it's going to be either positive infinity over positive infinity or negative infinity over negative infinity, which is still an indeterminate form. And of course, if you get 0 over 0, it's going to be indeterminate also, right? So you know, once it is that you have the indeterminate form, there's one of 3 things that you need to do. And you're going to go ahead and do it and solve those. All right. Here goes. Number 3, part B. So the question asks us to determine.
Sir, that one here need some alcohol for that one here.
Why?
Trust me, we didn't want some alcohol for that one here.
You know, my favorite character in Kelvita, you know why?
Why, sir?
You're going to be one of them who will go on to the other side when everybody sit down and say, give me some NSC. And you're going to come back with it in a covered container and go on like you drink orange juice and get drunk on way. True or false?
I plead the 5th.
I love it. I love it. All right, let's go, honey munches. All right. So, you know, when you look at the question, the truth of the matter is, yeah, especially if you have a fear of fractions, it may not come off nice. But it says, what is wrong? Come on. It says determine if the function g of x is continuous at x equals 0 and x equals 3. Don't worry about it. Sir tell you say, in order for the function to be continuous, the one year must be equal to the one year answer. True or false?
True.
True, sir.
Yeah, man. Yeah, man. And guess what? And the 1 year must be equal to the 1 year answer in order for the function to be continuous. Now, this is what I'm saying to you. They're asking us to find the value of x, the unknown, that will make this function g of x continuous. Now, think of it this way. You have a family, a nuclear family, mother, father, and then pregnant together and don't know what child it's going to be. That's exactly what it is, you know. Mother, father, don't have a clue what the sex is going to be. Them go do mini ultrasound, but guess what happened now? The child is smart. And the child say, you think me gonna show you what it is? I'm here to surprise you. And guess what now? The radiographer may say, oh, it looks like a boy. And you say, yeah, never get one boy. And you go buy all boy clothes. And when it come, bam, it's a girl. And some of you are saying, but I shall go wear the boy clothes and come in and buy nothing more. Not true. So This one family, G of X, contains 3 members, a nuclear family, mother, father, and this child that, you know, they never know what it is that the sex the child is going to be. Or you may even know, whatever it is. But this is it. So the point I'm making is that you have one function with 3 different functions inside of it. You have one family, one resident, one house, with 3 somebody live inside of there. All right? Watch me now. So remember, we need to investigate, as the question asked us, what is happening at x equals 0? What is happening when x lies between 0 and 3? And what happens when x is greater than 3? There are several things that we need to look at. Several things that we need to look at. So look at what is happening. We are saying, let us investigate what is happening at 0. So what is happening at 0? Well, there are only 2 numbers. There are only 2 numbers. You know what I'm going to do for you? I'm going to give you a question. Remind me on Tuesday, all being well, to generate a question for you where I give you 4 functions inside here. And I'm going to tell you why I want to give you the one with 4 functions. I don't know what the final exam is going to be like. I don't know what the final exam. I'm going to show you where you get 4 functions to show you that is the same thing that we have been doing, that we are going to continue to do. Nothing different. Watch me.
And when Sir gave the 4 function past the white lady here.
All right then. You see, Kelvita and Ryan, you can't travel on the same bus. When you can't travel on the same bus. Nope. And the tunnel can't drive either. Trouble. All right, let's go. So remember now, we're looking at a function to the left of 0, and we're looking at the function to the right of 0. Because remember, no, this is like us looking at the intuitive form. So we need to investigate both left and right of it. So left is less than. So we need to look at the function up here that talks about less than. The only one function talks about less than with the 0, and is this function 2x minus 3. So I'm using this condition to identify the function that deals with x less than 0, and it's going to be 2x minus 3. And with my 2x minus 3, I can say, okay, fine. When x is equal to 0, when x tends to 0, remember this negative sign up here, so you know the superscript is telling me that I'm looking at to the left of 0. All right. Now look at what is happening here. What I'm saying to you is, I am going to allow x to be equal to 0. So anywhere in the given function I see x, I'm going to put 0. So this is now going to be 2 times 0 squared minus 3. See here? 2 times 0 squared minus 3, and that is going to be equal to minus 3, right? You get a mark to show me that you have isolated the correct function. And how you isolate it, sir? This x to the negative to the left, this 0 to the left, has to go with this function. And that's where you get the mark. And when you evaluate the stuff, then you get the mark right here. Watch me now. When I look to the right, right means greater than. Right means greater than. So if you look at the function, you can put something over this. You're covering up this 3 bases here. So you can read it now. X, the alligator mouth is open, so it's going to be x is greater than or equals to 0. So this function is the one that is going to be greater than, which is to the right. So I'm going to put ax minus b. That's my function. Oh, but sir, the question asks us to find the value of x. So when I substitute x equals 0 here, so a times 0 is going to be equal to 0. So all I'm left with is negative b equals, well, it's just negative b. It's just negative b that I'm left with here now. But sir, in order for this to be continuous, these 2 functions to be continuous, that means this must be equal to this. Very, very good. Excellent. In order for the function to be continuous at x equals 0, the answer up here, so this negative 3 must be down here so also. So that one is supposed to be negative 3 also. But we don't reach here so yet. Or
sir, so what if you put the negative? What if you put the negative 3 there?
Right here?
Yeah.
That's fine. That's fine. Because that's fine, because if you really recognize b is not going to be negative 3, do you know? B is going to be positive 3 because we put a negative 3 for B. When you multiply this negative sign with the negative 3, we get a positive 3. And positive 3 and negative 3 are two different things. So B, the value of B itself is going to be positive 3. So that this, when you put that 3 right here, say it looks like the negative 3 up here. So that's why I don't want to put it here yet. Because remember, no, you get a different mark for that down somewhere down the bottom here. So let us just put this and leave this right here. So for now, and say soon come. And then we just move on to the other thing now, x equals 3. All right. If you want to put the line after this now, no, don't do it like that. I don't want to do it like that because I will tell you why when I get here. I don't want to do it like that. I want to evaluate x equals 0. What I'm trying to do is not to be prescriptive, but I'm trying to do it in such a way that you will always be able to follow and not make any mistakes. So when you get versatile on doing this thing now, then you can do anything you want to do. I could have evaluated the earlier up top, but I want to make sure that you understand it, especially that some of you were saying that you're having a challenge with the question. I want to make sure that you fully understand what is happening before. All right, so let's go. So now we're looking at x equals 3. We're looking at the function to see which of the functions up top. Matter of fact, do we have any interest in this function anymore?
No, sir.
No, sir.
No, sir. No, because this function is 0 and we finish with 0. So we have no interest with this function. We still have an interest with this function because this function straddles both 0 and 3. So this function will have to be used twice. This function is only it's going to be used once because it only have 3. This function will be used once because it only have 0. The function will be used 2 times because it have both 0 and 3. So you can look at it that way also. Watch me now. So what is going to happen here is I'm going to have x equals
Make it some AC, no?
Jesus, Father. Oh, you see that? Tell Peter, you see, you know, you. All right, no, I cannot speed in kind of up. All right. So what is happening here? So what is happening here is I'm looking at x equals 3. I'm looking at x equals 3. And x equals 3, I am going to be looking to the left of 3. Now, to the left of 3 is going to be, see here, this one here. We're forgetting about this 0 here, so no, forgetting about this 0. So we have x, the alligator mouth is closed right here, so it's going to be less than. So this is x is less than 3. So we know that this is a function that deals with x being less than 3. That's a function that deals with x being less than 3. All right? Now look at what happens. You remember the last time in class, I did that part last because I wanted to show you something. It doesn't matter which of them you look at first. If you look to the right first or the left first. Up here, so I look to the left first and then the right after. And down here, I look to the right first and the left. It really doesn't matter which of them you look at first, left or right. Really doesn't. So I looked at, okay, so let us go. So looking at to the left of 3, what I'm going to have is this function. So I'm going to write this function as ax minus b. Anywhere in the function I see x, I'm going to put 0. I mean 3, not 0, but 3. Anywhere in the function I see x, I'm going to put 3. So this is going to be a times 3 minus b. And a times 3 is going to be equal to 3a. A times 3 is going to be equal to 3a. So I'm going to have 3a right here minus b. I'm putting this one up. I'm not troubling this one yet. I'm putting it up. And look at what is happening here now. I'm going to be looking to the right of 3, but to the right of 3 is when x is greater than 3. This is the only function in the piecewise that deals with x is greater than 3. Yes, sir, it is greater than or equal to, yeah. Greater than or greater than or equal to, this is still the function. So watch me. You see, if they give you a fractional form in the test on Thursday, I don't want anybody to freak out. Don't be afraid of fractions. When you move to calculus 2, you're going to always work with fractions. When you work with Maclaurin's expansion, fractions. When you work with mean value theorem, fractions. When you work with trapezoidal, fractions. When you work with integration, fractions. All of them, fractions. So get with the fractions from now. All right? So let's go. Anywhere in the function I see x, I'm going to substitute 3. So I have x 2 times. So it's going to be 2 times 3 divided by 3 minus 1. 2 times 3 is 6. 3 minus 1 is 2. 6 divided by 2 is equal to 3. Now look at this. I think the question was 12 marks. 1, 2, 3, 4, 5, 6, 7, 8. You have all of 8 marks under your delta already. If you follow my steps, you are good to go. Now you have another 4 marks to get. And best believe you have 2 equations with 2 unknowns you're going to solve simultaneously. So that's why, was it you, Kelvita, or Yannick? That's why I was saying to you, don't just write b equals 3 right here, so. Because you have 4 more marks to get and you have to go show the working out in order to get those 4 marks. So when you isolate and show me now, my 2 equations that I'm working with, my negative b equals 3, remember now, so where you get negative b equals 3. In order tell me if you agree with that. Ah, the limits, LIMI.
And function, sir.
Yes, sir.
Okay, I'm not seeing what it says. Thank you. Come on now. All right, my screen. Right, must be equal. Thank you. Right? So what is happening here? They must be equal to 0. I mean, in order for it to be continuous, the limits must be equal. So therefore, all right. So now I'm solving simultaneously. But in order for the functions to be continuous, the limits for both must be equal. So therefore, I'm going to put negative b, this, up top here, sorry. This negative b must be equals to 3, and that forms one equation. And then 3a minus b is also equals to 3, that forms the second equation. Am I understood there?
3a minus b?
Yes, sir. Yes, sir.
Yeah, man. See there, 3a minus b. Remember, we multiplied this 3 by a to give me 3a, and it's minus b, right? So this 3a minus b must be equal to this 3 for this one to be continuous, and these two must be equal in order for it to be continuous. And that's why I was able to formulate my equations, my simultaneous equations this way, by putting them equal. See here, the 3a minus b is equal to 3. See here, 3a minus b is equal to 3. So I have to do that.
Explain it like that.
Sir.
Huh?
First, you explain it like that, you know.
No man, sure, no man, I did this for the. No man.
How you tell us where you get it to form the equation?
Okay, all right, fine. And that's why it's important when we do these sort of questions. All right, fine. But remember now, this sort of simultaneous equation comes only when you have the unknown to work with. So let me just put that plug in there also. Your simultaneous equation only comes when you have that unknown to unravel. But okay, fine. I'm happy that my explanation is a little bit clearer, based on what Sashi was saying, that is the first kind of hearing how I formulated my simultaneous equation. So just let me reiterate that point so it is that it can be cemented So in order for us to have continuity, this one, okay, I'm going to say something and you tell me if it's the first you're hearing this. The limit to the left must be equal to the limit to the right for the function to be continuous. True or false?
True.
True. All right. Is the person hearing that?
No,
No,
sir.
sir. No, sir.
I'm hearing up. But what Sashi said is that it's not the first you're hearing it, but it's the first you kind of see now that what it is that we're doing here. So it's not the first time I'm saying it, but you're seeing it differently now. So let me just bring all the ideas together. The limit to the left, see here, x to the zero, zero is 0 to the negative sign and 0 to the plus. This is to the left, this is to the right. In order for the function to be continuous, to the left of the function must be equal to the right of the function. We say that it is behaving well, it is of a good behavior when the left-hand side is equal to the right-hand side, and that's when we have continuity. When we have the left-hand side having a different look to the right-hand side, it is going to be discontinuous. It is of a bad behavior. So both must be going in the same direction for the function to be continuous. So what I'm saying to you is, them two you must be equal. So we have to go put this -3 to be equals to negative b. See it right here, so -3 equals negative b. But sir, now that you have negative b equals negative, same difference. It's an equal sign, so it can be read either way. Normally we put the ones with the unknown, however, on the left-hand side. All right, watch me now. It's the same way. In order for the function to be continuous here, I must have the left of the limit to be equal to the right of the limit in this case. So that means 3a minus b must be equals to 3. So now I have my simultaneous equations. I give you a mark for being able to formulate your simultaneous equation. So why do you give a mark for that? Because you must have that understanding that the left of the limit is going to be equal to the right of the limit for continuity. And the question did say to you, find the value of x for which the function is going to be continuous. Sometimes you may see for the function to be continuous over positive infinity and negative infinity, you know, then pretty something there, same difference. So here I'm going to be using the elimination method. So this one, this first equation, when I wrote the question, sorry, go ahead, Aviana.
All right, so for the first part where you have negative b, I had the a times 0 minus b to be equal to -3. So when I went to the simultaneous section, I have a minus b equal -3. Would I lose a mark for that?
Aviana, you see what they said to me up front was perfectly fine. I was right there with you because I'm going to say, okay, if you chose to write a times 0 minus b equals -3, it's fine. But what is a times 0, Abby?
All right, sir.
Ah, very nice. So you see where you went wrong here, right? Because
Yes,
you can't just drop the 0 and keep the a. If you keep the a, you're going to get it wrong. And again, I'm going to thank you for your honesty. Very good. Very, very good. Because to be honest with you, you would have helped somebody in class today.
Yeah, that me did have first and then me change it.
Same thing, you know? Very good.
Yeah.
A times 0, 0, don't.
0 to anything is 0.
I think it's be a money smell.
No. Is that right, Jeremy?
No, reach up to yourself, up to yourself, good enough.
Okay, good. You said something a while ago, honey bunches, that I want to correct. You said anything to the 0 is not anything to the 0 here because anything to the 0 gives you 1.
Sir, I said anything times 0.
Very good. Maybe I need some whites. That's why I was hearing something different. Or maybe I had too much.
No, sir. I tell you, sir, Ryan, why you drink for right that question here?
No, sir.
All you roommates in this class, you see? Anyhow, oh, sorry, we're being recorded. Jeez, I'm not gonna lose a little work, you know. All right, let's go.
Sir.
Move on, sir. Go on first, Andrew.
Yes. What if I have the working note, but the explanation of would that deduct a mark or something?
If you have the working note without
like right here you have using elimination method.
No man, you see other than notes here, and for your purpose when you look on something, you know, you may say to me,
okay,
what's your move from here to your so I tell you, so but in the exam you don't have to do this. Funny story. I was teaching a business calculus class to a student who claims that she don't like math. And I'm telling you, that student struggled through the associate. They give her 5 years to complete the associate degree, and she was at the point of being realigned at the associate degree level. And I said to the student, come back for the bachelor's, and she tossed me out. No, sir. I said, listen, bird can't fly on one wing. You have to come and do the bachelor's. And she came and I said, as a matter of fact, you say, oh, you struggle for the associate degree? You know, you're not foolishness for the bachelor's year. A one shot you're going to go through. And I'm going to tell you, it came to pass. The student graduated last year. And at the graduation ceremony, when I saw her picture, I mean, I'm not lie to you, tears filled my eyes because I know what struggle she went through for the associates. And this maybe is going to encourage somebody here. I'm not concerned how long you took to finish your associates, or if you never finish your associates with high marks. You're now in the bachelor's in the first semester that you can undo. What it is that you got for the associate degree will not go towards the bachelor's because it's two separate awards. All right. And I remember, just as I'm teaching here, Andrew, by talking about using the elimination method, you see when good girl went at the exam and I mark her paper, now using the elimination method. And it was so encouraging. I mean, I was so pleased with what was happening. And I'm going to tell you, the student got an A for the course. Now, somebody who claims that they don't understand math, and this wasn't COVID time, you know. To say she had the notes in front of her. This was her going in and doing a paper-based exam. And I just smiled, and you know, when I marked the paper, I said, you know, this student really got it. She is doing pretty well. So it is to encourage somebody here tonight that I'm not concerned about how long your associate took you, or if it is that you got all, or you see your way through the associate. That's not my concern. My concern now is that you have a new slate and you're going to continue. All right, let's go.
Wait, a question. What's the difference between business calculus and calculus?
And calculus 1?
Yeah.
Calculus 1 is goes a little bit more in depth than business calculus. Business calculus is just really teaching calculus from a business perspective. Calculus 1 now encapsulates, you know, that sort of business perspective and a computer perspective. It's a general sort of stuff. So especially in calculus 2, you will see where it is that we look at you're going to do applications of differentiation and integration here in calculus 1, but we also have application type questions in calculus 2 to show you how, you know, you can actually use calculus 2 in your current field, ICT, right, or computing or IT, whatever you want to call it, BMIS, them something here. So it's a little bit easier than what it is that you're doing. To be honest with you, these are the hardest math courses that we offer within the institution at the bachelor's level. Calculus 1, Calculus 2, right? So you guys are a cut above the others. Real talk. All right, let's go. So what I'm doing, I'm dividing both sides by negative 1. So I'm going to get B equals positive 3. So this one was easy. But you know what I'm happy about? Quite a number of you, all right, let me just put it up. Quite a number of you would have lost the mark right here. You know why? Because you would have seen early up top. You'd have seen early up here, so that B is going to be equals to 3. And maybe lose this mark, but get this B equals 3 mark. And then when you get the B equals 3 mark, you just say, you know what, I'm going to substitute B equals 3 right here. So I'm going to substitute B equals 3 right here, so you can't get the other 2 marks here. So you end up getting 9 out of 10. What I'm saying,
I lose marks for B equals 3. That's so.
Same thing. I really want you guys to This 3 marks.
Last stream that we stop before we stop right there using elimination method.
So we
forgot, honestly, forgot totally about that part there.
All right, let's go. So what I'm going to do now is to put B equals 3 into the equation. So I'm going to now substitute. Now, I could only use equation 1.
Sir.
Yes, please.
For B equals 3, what if I had completed that at the above in the equation at top?
That's what I just said.
I said. Oh, so it's okay. Right.
Yeah, I said it. But did you write this? Did you write this, Andrew? No.
No.
I know. That's what I was just saying. So a lot of you would have seen B equals 3 from up top. And based on the nature of the question, because he eliminated A from up top, is when I wrote the question, I said, oh crap. The question that I wrote eliminates A. And I say, you know what? Let it stay. Because I don't want them going to the exam and A is eliminated early and then turn full. So let me give them one to at least them see that A. The other questions that I gave you ended up with 2 sets of simultaneous equations where you have both A and B. True or false?
True, sir.
Come on. So when I wrote the question the other night morning, I said to myself, no, let it stay, because who to tell? Maybe you get a question on the final paper or the mid-semester where one of the variables is cancelled out pretty early. So there goes. All right. So I'm going to substitute B equals 3 right here.
Sir,
For that,
before you jump on there, sir. When using elimination method, isn't that where you normally do something that's caused one of the...
Very good. That's exactly what I just said. Right. So what Yannick is asking, if it's we normally eliminate one of the variables.
Oh, it's me. It's talking to her. Yes.
Yes, sir. Right. So you ask the question, Yannick, and I'm agreeing with you. So at this stage is where we normally go and eliminate one of the stuff, but one of the variables was already eliminated for us. All right. So
you could have just used that one.
Very good. Very good. So you see how quickly we got one of the answers, Yanni, because the A was eliminated from up top.
Sir, that's why I did go back and do it up top, because when I reached that stage, I was saying to myself, then me I got eliminate A, because in my head I'm saying I need to eliminate A from both of them, both equations.
Right.
Or you usually use it to cancel out each other.
Very good.
So when I didn't see that is possible, I went back up top and just found B same time. So when you have the simultaneous equation, instead of having minus negative B equal negative 3, I have B equal 3 for my equation.
And that's fine.
There are pure foolishness, pure.
No, but never mind, Sash, and you'll be fine. Don't even get flustered now on me. You're fine. You are fine. You will be fine. Don't worry about it. You are learning. That's one of the things I can say to you, Sash. You are learning, and I love your energy. And you are one of those who, when things now go right, you're gonna make me know it now go right. So that's very good.
Johnson.
No man, Sash, good man. So what I was saying to Andrew Yannick is that when I wrote the question, I recognized that my A was eliminated up top. I was like, no, we write another question. And then I said to myself, but why? Suppose I'm going to the exam and then get a question of this sort. I don't want them to go into the exam and turn idiot. I want them to be able to see exactly how sir do it. But Andrew, you were trying to come in when Yannick was coming in. So come now, Andrew.
Oh, what I wanted to say was that I made a mistake of doing out that section of the equation in my head. I didn't write it down. So that was my mistake.
Yeah, fair enough. But so you hear what he says. You know who love to do that too? Jermaine. Love to do the calculation. What sir? I don't need to write that. Yeah, but I want to see some people. I want to see it and this is why I said to you that bright students sometimes come out of an exam with 80%, and the ones who don't know that they are bright come out with 100%, because the bright students do the calculation in their head and just put down what they feel like putting down on paper, and because they don't see the working out, them can't get the mark. So what I want you to do is to write it out. Remember, when you're doing your question, yes, Jermaine, is you are just talking about. Is when you do the question, guys. Remember, it's a language, so whatever you're putting on paper, you're communicating to me. You're communicating to me to say, sir, I am going to now substitute this into this. You don't have to write the narrative like I do. Remember, I only write the narrative because I want, when you're looking back at this outside of my presence and you see, oh, this is what sir is doing. Oh, yes, that's what sir is doing. I want to make sure that you are understanding, because I'm leaving this with you, and hopefully at some point in time, when you're reading through, you can hear my annoying voice into your headspace saying, no, You have to do this and you have to do that. Anyhow, what I'm going to be doing here is substitute. I'm putting my b equals 3 in this function here. So this now becomes 3a minus 3 is equals to 3. And I'm adding 3 to both sides. So I'm going to have 3 plus 3 is equals to 6. And 3a equals 6. When I divide both sides by 3, I'm going to get a equals 2. Kelvita, never mind. Love you more. Love you more. All right. So
one question before you move on.
Go ahead, Onibon, please. Nika, talk to me. Yes, Nika, boo. What's up?
Sir, I don't have no that a minus negative 3 and the 1 month before the elimination. So sir, I don't have that right like that.
Yeah.
So what I did was I got the negative 3 equal the negative b equal negative 3 at the top.
Good.
And then I work out the limit for the 3 and then I get the 3a minus b equal 3. I'm gonna put equal 3 too. Then I substitute everywhere must see the negative b. I put negative 3. Then I get a. Then I'm gonna get a. I go back around and solve for b again. So would me lose mark for?
All right. So no, man, you're cutting the story short on Nika. So tell me now. So what you got for a?
So I got a equal to. So I got the answer and everything is right.
So guess what now? Based on what you just said to me, you didn't set it out like this, but you have on paper both of these equations. Now, when I'm going through and I see both equations, I would have given you the mark.
Okay.
So you'd have got the full mark for it. Because based on what you just read, I heard you say you have this second equation, 3a minus b equals 3.
Yes, I'm set it up, but I just never put them together like that.
You're good, man. You're good. All right. Now, let me just say something here now. Davia, you have not said a word to me. Karika, I don't hear nothing from you. Lexton, we can't understand Lexton. Today a camera day and Lexton come to school without camera on device. I'm gonna hear nothing from Lexton from the night. Nestor. Zidane, you know, put on the shirt yet? Put it off, put on the camera. Is it in?
Yes, sir.
So when I talk to me, I talk to you. Me now hear from you. Are you understanding what is happening?
Yes, sir. Yes, sir.
Okay. But tell me what you understand, Zidane. And don't tell me everything. Tell me something that you understand.
Sir, I understand well, I can't really explain what I understand, but I understand.
You can't explain that, you don't understand it?
No, sir, it's just that I am a person who have issues explain myself, that's why.
No. Stop right there. You notice when and this is not just for you alone. So I don't want at any point Lambert to think that I'm attacking you. I'm not that guy. But you notice when I'm doing the question, I will say to the class, what is your first step? Because if you know what it is that you're doing, you are good to go. So you have to be able to verbalize what it is that you're doing. Mathematics is a language. It is a language that we speak in math. So everything that I'm teaching here, if somebody in Timbuktu reads my notes or watches my video on YouTube, should be able to understand how the question is done, because it is the same language that we speak. So I'm saying to you, what I want your homework, Zidane, is to go and look at the question and to make sure that you can verbalize what it is that you're doing. I'm telling you, if you can verbalize the steps in a question, when you go into the exam or doing whatever it is, you can know this comes first, this comes second, and trust me, you can't go wrong. You can't go wrong. All right, so you have to do. So that's exactly what happens when a doctor goes when a doctor goes to see a patient, there are several things the doctor will say. Have you been having diarrhea? Are you coughing? Are you running a temperature? Have you lost your taste? And if all of those are yes, oh my goodness, come, let us do a COVID test. That's the first thing, right? So you have to make sure that you can be able to verbalize. All right, let's go. All right, thank you, sir. Who else I don't hear from? Nesta, I don't hear from you. Miss Smith, I don't hear from you. Wint. All of you people are in charge, do you know?
Sir.
Yes, please.
Earlier I was talking to you, but it appears you weren't hearing me because of my earphone.
Oh no, I ignored you. That's what you're saying?
Sorry?
I ignored you?
Well, yeah.
Oh no, that's not a nice thing to say. But can you turn your camera on, please? Everybody have them camera on. So why are you hiding?
Sir, JPS lock off my line.
Anyway, go on, talk to me. Yeah, man. All right. I'm happy that you are here and you're following. Let me see who else I'm not hearing from. Chetty spoke to me tonight. Davia, I have not heard anything from you, but never mind. You and Dad will have conversation.
Sir,
yes,
I am
please.
okay so far, so I'm just waiting for you to go to the last question, sir.
But Davia, so tell me now. So come in, chime in one time and say, yes, sir. This is Davia. I'm understanding. I have to look up for you, Davia. You have to talk to teacher,
okay,
man.
sir.
Sure. Thank you, man. Sure. You know,
Sorry,
there's somebody.
scroll up a little for me, please.
Scroll up a little for you.
To the first part of this question.
Okay. Like right here?
Yes.
Let me talk about the question and just put it right there. Yeah, man. All right. So Lambert, so again, coming back to you, coming back to the others, when you are, for example, factorizing, one of the things that I really want you to do is to say, I'm going to be multiplying the coefficient of x squared by the constant. All right? Because when you know that, and then when you know that it can't go wrong, and then when you multiply the coefficient of x squared by the constant, then you're going to say that, no, I need to prime factorize because I need two numbers. When multiplied together is when it gives me the product of the first and the last term. And when I add them, I'm going to get the middle term. So I'm going to be multiplying the terms on the outside, find two numbers that when multiplied together will give me the product of these two numbers, but when added will give me the middle number. It's very important. It's very important for you to be able to verbalize. What does that mean? Can I move from here?
Yes.
All right, good.
Yes, sir.
All right.
Next question.
So this is a question that everybody wants to find out.
I know, sir. The last one.
The last one.
You know, you see, Charlene.
Sir, before you move on to see those, sir, yeah. when me really assign us, sir, is that the question not really look done, because the question say we must determine if it continuous. So I'm not supposed to have a statement at the end of that saying that yes, it continues.
Let me go back to the question, dearest, because I mean, you're supposed to have a statement. Can you correct? Is the function is continuous at the point x equal? No. I wrote the question wrong.
Okay.
I wrote the question wrong. What I should have written is find the value of A and B.
Sir, that's somebody confusing us, sir.
I'm sorry, I apologize. Determine the value of A.
Sir, we could I get full marks, sir?
No, man, that's fine. A and D. So determine the value of A and B. The piecewise function continuous.
So you're gonna send them a note, right?
Absolutely, as per usual.
Thank you very much.
That's why I'm a bit confused now, sir.
All right, no problem, honey bun. Just continuous. All right. All right. Thanks for pointing that out. You know, one of the challenges is when you love to copy and paste. I had just copied and pasted something right there. And wrote a function. Okay, so that is fine now. So you wanted to find the value of A and B. So that was that. So yes, Yannick. So if the question had asked us to find, you know, the normal type of question that would have given for us to do the statement, yeah, but this one here is a little different because I wanted to find A and B. That's why I said therefore A is equals to 2 and B equals 3. All right. Nobody has a problem with this question.
Easy cheesy.
Easy cheesy, yeah, man. But I'm going to go through the question nonetheless. I'm not taking anything for granted. But so this is what is happening. Oh goodness, let me just check for time. Oh, feel like I'm just ready to start class. All right, so if you look at the function here, it says differentiate the following from first principles, and you have f of x is equal to 3x squared minus 7x plus 5. And remember, you always have your function. You always have your function with the limit as h tends to 0 of f of x plus h minus f of x all over h. Sir, do you always do that? Absolutely. 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 F of x minus h. So you have to always have the function written out like that. It's very important. Very, 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 very important. You must have the function like that. You can't go through without doing that because you're gonna get into some serious problems. Really, really, really serious problems. All right, let's go. So anywhere in the function I see x, I must put my x plus 8. Anywhere in the function I see x, I must put my x plus 8. Very, very important. Watch me. The limit as h tends to 0 of 3 times x plus h all squares minus 7 times x plus h plus 5. And then now I'm going to be subtracting the function minus all of the original f of x that was given, which is here. Students, remember, very important that we are going to be enclosing the function in parentheses. It's very important that you're going to be enclosing the function into parentheses. Very, very important. Very, very important that you're going to be enclosing the function into parentheses. If you don't enclose the function into parentheses, when you are multiplying by that negative sign, you're going to be having a difficulty. You're going to be having a difficulty if you don't enclose it in parentheses. All right? So make sure that you enclose your function into parentheses before you do anything else. Very,
Andrew,
very...
mute. Andrew, I'm telling Andrew to mute.
Oh, to mute. Okay. All right. So it's very, very, very important, right? So what is going to happen is if you don't put it in parentheses, you're going to have some serious problems. So please make sure that this last piece here is enclosed in parentheses. All right. So that is not the issue. That is not the issue. The issue now is, well, the issue will be the last question. So let us just finish off this one. So remember, when you're expanding, come slash. Come in now, leave it right here, say no slash. Come.
Sir, I'm gonna put the invisible one there.
You don't have to. No.
That's what I was going to ask.
Yeah, man. Remember now, you know, as Andrew asked the question, is there a lot of things that I put into this document? It's only placed there for explanation when you are going through. You know, sometimes you take up one book and you read and you say, oh, then get this because the book not tell you how you do it. It's not a book I'm writing. I'm giving you notes. I'm trying to explain, which is why I can't just teach using a tablet where I can't write, because you notice every night I come to class, I am amending the document based on a question that is asked. I'm going to itch up something here to give you further explanation, because I want when you're going through the document on your own, you have it and you can do it and you can replicate the information. All right. Now, watch me. So I'm showing you that this x plus h, like when you go into the exam, you don't have to write this up here. So me want to write this to show you that x plus h all squares is x plus h times x plus h. That's what I'm doing. All right. So let's go. We know that x plus h times x plus h is going to be x squared plus 2hx plus h squared. All right. So this is what it is that we're doing. This is what it is that we're doing. And then what I've done is just write everything right back right here. So, sir, why? Because I don't want to mix up with something. I want to be able to just remove the brackets all at once, which is in this line, right? What I try to do, students, is to be very systematic in how I'm doing my questions. And I do that how I teach also, because I want to develop your brain in a manner where it is that you do things piecewise, no pun intended, right? Let's go. So the only thing that I'm doing for this line, the difference between this line and this line is that I am, other than I remove the one here because I'm showing that the one don't have to be there. That's why I put it in blue in the first place. Is to show you that this x plus h all squares is going to be x squared plus 2hx plus h squares. All right. So when I do this, now I'm going to remove the parentheses. Watch me. 3 times x squared is 3x squared. 3 times 2hx is going to be 6hx. 3 times h squared is going to be 3h squared. Minus 7 times x is minus 7x. Minus 7 times h is going to be minus 7h. And of course, my plus 5 is a standalone. Sir, how you know it's a standalone? Why never multiply it out? Because this 5 is sandwiched between a positive sign and a negative sign. So this 5 is not multiplied by anything. It's a standalone, so I have to put it back. Watch me. This negative 1 is an imaginary one that is there. Multiplied by 3x squared is going to give me negative 3x squares. Right here. This negative 1 times the negative 7x is going to give me a positive 7x. And this negative 1 times a positive 5 is going to be a negative 5. So I would have successfully removed my parentheses. All I'm going to be doing now is my cancellation. Then, sir, you'd have to write back the question to do the cancellation. No, I am teaching you. So I want to show you what the something look like without the cross up. And then I'm now showing you the cancellation here. Now remember, you see everything right here, sir? My f of x.
But sir, you have 1 mark this, so.
Yeah, man, because I want you to show me here. I want you to show me here, you know. So when you double it up, you will get 2 marks. But I am doing it here because I'm separating it right here. All right? But watch me here, so. Watch me here, so. I'm just reminding you, everything inside this parentheses, everything right in here, so, is going to be canceled out. Because remember, I'm taking out my f of x, and then I'm going to leave now with my incremental change. So my incremental change is going to be there. So all of my f of x, I'm going to be pulling out of the function. And whatsoever is left, put it this way. Andrew start a little computer business. And Andrew say, I'm tired to work with people. And Andrew, well, I'm not speaking anything into Andrew's life, but Andrew's company decides, say, them are going to make him redundant and pay him off about $2.5 million. And Andrew say, well, I'm going to start a little team for my own, you know. And Andrew invest the whole $2.5 million in setting up his business. Right? And over time, Andrew's business is doing very well. And his profit now stands at $3 million. What Andrew can say is, I'm going to take out my $2.5 million, my investment, and that investment now is going to be placed in a fixed deposit for my eventual retirement. And that $500,000 is going to now turn over into the company. That's exactly what it is that we're doing. For the stuff, we are going to be putting in the function, the incremental change, and then we're taking out what the function is, and then we're going to have the incremental change. And that's what it is that we're going to be working with. Right,
Sounds good, sir. Sounds good.
Oh,
yes,
oh,
sir.
Like,
Yeah, it sounds good. Yeah, man, speak it into being, sir. Speak it into being. Tired of work for people.
Same way, so. Same way, so. All right, then. But remember, when you get rich, you have to remember your teacher, you know. Can't just leave the teacher alone here. You know, answer the other one there.
No worry, man. No worry, sir. Not gonna forget about you.
All right.
Where's the curry lobster? Or actually, which one?
Tell you. Tell you. All right, let's go. So now we're going to be canceling out all of these. And when we cancel out, remember, we're taking out all of, so remember, we have how many terms here now? 1, 2, 3 terms. That means them 3 something you're going to cancel out with 3 something up here. So we're supposed to have 6 cross out. Let me check. 1, 2, 3, 4, 5, 6. Magic. So we have to make sure, say, we're crossing out them 3 something. So each of these must be paired with something that we can cross out. So we have a -5 right here. So we must have a +5 inside somewhere here. So and see it. And see the +5 right here. We have a +7x here. So we must have a -7x. See it right here. So and we have a -3x squared. We must have a +3x squared. See it right here. So when we cancel out those now, what should be left? And I'm emphasizing this for the question beneath. What should be left are terms only in H. So we must have H in all of the terms. Every single one of the terms we must have H. All right? So look at this. We're going to be left with 6hx plus 3h squared minus 7h. Then I'm going to be factoring out my H. So I write a line to show you that I'm factoring out the H. And then now I'm just going to have 6x plus 3h minus 7. My H is cancelled. So I now have 6x minus 7. All right, well, I have a 6x plus 3h minus 7. And then what I'm going to be doing is finding the limit now as h tends to 0. So I'm going to substitute 0 right here. So when I substitute 0 here, this is what results from that. What results from that, then I'm now going to find the limit as h tends to 0 of 6x minus 7. Let me see those of you who remember what is happening here. What do I say right here? Why do I have this written back again here?
Because it's a constant, sir.
The limit of a constant is the constant itself.
The limit of a constant is a constant itself. Guys, I mean, just do what you're supposed to do, you're good to go. I'm telling you, I have seen what the mid semester looks like. And if you guys truly understand everything that is we have done so far, the lowest percent I should be accepting is 85. I give you an opportunity to make some mistakes. 50% with a mistake. Right? And anybody who gets 100% out of that 2.5 billion, and you're giving $1,000 a year, let's go on. Let's move on. All right. You laugh. Let's go. So
I'll give myself $1,000 too.
Trust me, same way, sir.
Sir, question before we move on, sir.
Huh?
Sir, question before we move on. You can go up a bit, please.
Sure.
Right here where you do the cross notes, sir. What I would know up further? You said that what I would do, I would just write the expression below it without putting the cross out. Would that be okay?
It will be okay, but just remember now that you need to isolate what is going to be left. And why I cross it out is to show me what is going to be left. So I would recommend that you do that. But it should be fine.
So I don't have to do the crossing out then?
No, that's what I said. I want you to do the crossing out because at least you'll be able to see what is left.
All right.
What I'm saying to you, Zedin, is that okay, is it for me now? Is it because me know how to do something? Me can know say this is going to be in there, this is going to be in there, and this is going to be in there. But because you are in the developmental stages, I want you to cross it out to see what is going to be left. You go to supermarket today, you don't want to buy bread 2 times. So you go cross it off of the list. That's all.
All right, understand.
Yeah, man. All right, cool. One thing before I go though to the other question, and this is just a little break. So Andrew said that he would have really pay pay himself $1,000. And it's something that I am a firm believer on. It is useless for us to be working to pay mortgage on a house, mortgage on a car, school fee, on a treat on yourself. After you take out on the tithes, on a treat on yourself to something. Even if it's $1,000 worth of food, every month you need to treat yourself to something. Real talk. And don't tell me, say, sir, I can't afford it. No. I'm not going to say, must go buy a new phone every month. But every month you have to treat yourself to something. And you don't have
enjoy
to
life.
At least
absolutely.
the country, sir.
Yeah, man. And you know what you can do too? You may say to yourself, say, boy, when I want, me can get at the end of each month. So the end of each month, you find one account where you're going to drop $1,000 in and you have no card fee. So when you want the money, you can't. You say, sure, yeah, me can't bother going to the bank because stand up, you dash with the card, then you can cut it up. So you know that you have that compulsory saving. Right? All right. Yes, next done. Me see that. All right, let's go. All right, Charlene, I hear that you wake up now because you reach your question.
Yes, sir.
So the fractional one isn't any different from what it, yeah, let me not say that. The fractional one you have to be very keen on looking at in doing the question. Because though the concepts are the same, you have to call it Mr. Fraction. You have to put some title to it. All right. So we know the formula. The limit as h tends to 0 of f of x plus h minus f of x all over h. We have that part. Look at the function. The function is, let me just do this. Look at the function. The function is f of x is equal to 4x over x minus 1. Anywhere in the function I see x, I'm going to put my incremental change, which is x plus h. See here, 4 x plus h, x plus h minus 1, and then I'm going to subtract the original function, which is 4x over x minus 1. Then, sir, I don't see divided by h. Remember I said to you that dividing by h is the same thing as multiplying by its reciprocal. Dividing by h is the same as multiplying by its reciprocal. Tom, what am I thinking about?
You know, so I made a right, but wait, I have to type it for see if I did here, right?
So you hear the same thing?
It's not the same. It's not what you type here, right? But they get yourself.
What
said dividing by h is the same as dividing by its reciprocal instead of multiplying.
Oh, yeah. The mind is going very fast. The mind is going very fast. Yeah. So that's why I did this piece here. Let me just save this thing here because, all right, cool. So that's why I did this piece here, and I converted it to the reciprocal, and I'm multiplying by it, right? Remember the opposite of multiplication is division. So let's go. So having done this, my aim now is to put, you notice that this here is the same thing as I have here, except that I am now distributing these parentheses. So it's 4 times x to give me 4x, 4 times h to give me 4h, and this x plus h minus 1 is just x plus h minus 1. So this line is just me kind of fixing up this a little bit because I know I'm going to have some more brackets. I'm going to introduce more parentheses in the function. So I don't want to have too many parentheses in it. So I just remove this one here so I can have space for the others. That's all I'm doing. So this is what I did. I removed them so I can have space for the others. Then, sir, why did you put back the parentheses right here? So because I know I'm going to multiply this term by this term, and I want to be able to separate them. Why, sir? Because I'm finding the lowest common multiple. I'm finding the lowest common multiple. So in finding the lowest common multiple, what I'm going to be doing is going to be multiplying my denominators. So this now becomes x minus 1 times x plus h minus 1. So I'm multiplying these two things right here. These two things are being multiplied right there. Now, when I multiply these two things here, I'm going to say to myself, when x plus h minus 1 into this denominator leaves x minus 1. Why, sir? Because all of this cancels out with all of that. So all I'm going to be left with is x minus 1. So it now becomes x minus 1 multiplied by 4x plus 4h. See here? X minus 1 multiplied by 4x plus 4h. Watch this again now. How many times can x minus 1 go into all of this down here? So this x minus 1 cancels out with this x minus 1. So what is left is x plus h minus 1. So I'm going to say now x plus h minus 1 multiplied by -4. You can't leave out this sign. It's a -4. So watch me. This -4 multiplied by the x plus h minus 1. And of course, you're still going to have your 1 over h, 1 over h, 1 over h. Now, all I'm going to be doing right here is to remove these parentheses because I'm suspecting now that I'm going to have some levels of calculation, elimination, cancellation to be done. So watch the distribution now. Okay, so what I did right here is just to take out this piece because this is a portion now that I'm interested in. This is a portion that I'm interested in. What I'm going to do is nope. Nope. Oh, yeah, not going to work because it's a division sign. So I wanted to highlight that, but it's a division sign. So let me just highlight this one here. So I can't do that. So let me just do this one down here instead. So the point I'm trying to make here is that this piece here in blue that I've just highlighted is this section that I've taken out because I'm no longer interested in this piece up here because this piece up here is now being represented by this piece down here. So this is the only piece now that I'm going to be taking out, of course, with the 1 over h. All right. So having done that, I'm going to be distributing, removing my parentheses. I'm distributing this x minus 1 over the 4x plus 4h. So x multiplied by 4x gives me 4x squared. I want you to watch me. Please, let's go again. X multiplied by 4x goes 4x squared times. This x again multiplied by 4h gives me positive 4hx because this x has to multiply everything in this parentheses and then this -1 is going to multiply everything in the same parentheses. So let's go again. X times 4x gives me 4x squared. X times positive 4h gives me positive 4hx. Then I'm moving to my -1. -1 times 4x gives me -4x. And the -1 times a positive 4h gives me -4h, which is this term here. And then what I did was to multiply the 4x. So what I did was to leave this negative sign, my separator here, and just multiply this 4x by this x to give me 4x squared, and the 4x by h to give me 4hx, and the 4x by the -1 to give me -4x, right here. And then in this line here, I'm going to be removing my parentheses. So this -1 now, multiplied by 4x squared will give me -4, this -4x squared. This -1 times a positive 4hx gives me a -4hx. And this -1 times a -4x will give me a positive 4x. Now watch me. In this parentheses here, this is my f of x. Remember, f of x plus h minus my f of x. I'm supposed to be having some cancellation. So this in the bracket, the 1 here in the bracket, and another 1 here in the bracket. Any number of terms in the bracket, you can almost times it by 2 to know how many terms you're going to cancel out. So I have 3 terms right here. So times 2 is 6 something I'm going to cancel out. So if you have 1, 2, 3, 4, 5, 6, because everything right here, so in the parentheses here, must be able to be canceled out with something up top right here. This negative 4x squared is going to be canceled here. This positive 4hx cancels with this one, and this negative 4x is cancelled with the positive 4x. So I'm going to be left with here with a negative 4h. See it here, so? And I wrap up my denominator. Sir, what are we going to do with the denominator? We're not troubling the denominator. We never ever trouble the denominator. Let us just work with the numerator because the denominator is crisp and curry. It is fine. So we're going to expand it? Absolutely not. Not expanding it at all. All right, let's go. So of course, all of that is still being multiplied by 1 over h. All of that is still being multiplied by 1 over h. So look at what is happening here now. Now it is that I have to do, remember, no, I can't find the limit of the function yet until I get rid of this h. That is a trick to the thing, you know. So why? Because if I don't, remember this h is being divided by all of this, you know. And if I put h under here, which is the same thing as 1 over h, and I put him as 0 right here, so it means I'm going to multiply, I'm going to divide by 0. That means the whole function is undefined. So the only time you can find the limit of the function is until you get rid of this divided by h sort of situation. Anytime you divide by the h, then that's the time you can find the limit of the function. Right? So you're going through all of this, so it is that you can eliminate this divided by h. Watch me. So this h, and this is what is important for the fractional form. And if you get a question in the fractional form, always write it as a 1 over h. Always write it like something like so. Because look at what is happening here now. This h is going to cancel with this h right here. So and when I cancel it, I'm going to be left with negative h. See that, so? This cancels with this. So I'm going to be left with a negative h. A negative 4, I'm sorry. And when I'm left with that negative 4, what I'm going to have now is negative 4 over all of that. Oh, sir, that means you get rid of this 1 over h. That means you can find the limit now. Absolutely. Absolutely. All right. So now we are able to evaluate the limit of the function. Krishna, where you gone? You all right? You still there?
Yes, sir, I'm there.
Oh, okay, okay. So kind of silent, that's why. Kay, is it all right? Because laundering some white.
No, man, no good.
All right, cool, nice. All right.
My book up and catch it.
All right, nice.
But so, I didn't bring down the negative with the 4h.
That's fine. Now you see. Now, so what is happening? So now we're able to find the limit of the function. So anywhere in the function I see h, I'm going to put 0. So see here, so I one of the 0, I one h they don't know. So I'm going to put the 0 right here. So when I do that, I'm going to only have no x minus 1. So this is what I have now, negative 4 over x minus 1 times x minus 1. And then that's how we're going to get the negative 4 over x minus 1 squared. And that gives us our final answer for the question. And that's it. Final answer for the question, and that's it.
So you have to put back the limit h tends to 0.
No,
I just would equal to.
No. You're correct. You're correct. Yeah, that's it.
Mr. Shen.
Yes, sir.
How long would the test be?
How long will the test be?
Yes, sir.
I'd have to go and look back at the paper. CCCJ would have sent it. Normally,
I want to ask that question when you finish.
Yeah, you can ask the question because I'm actually trying to look at something. Go ahead.
No, it's It's from the working out, sir.
Sir, you have to go back over the third line, sir. Right there, sir. I just not get right there, sir.
And that's fine. That's fine. I will definitely do that for you. Just let me just tell you.
Where is that there for you?
Say it again. What was that?
Oh, not sorry.
No. They didn't tell me no time. They don't tell me no time, you know. Let's see.
Normally when I get like mid-semester, just get it for the rest of the class.
Oh, that's what you thought. I may give you about, no man, remember it's a 3 hour class we're having, so I will give you, I won't give you 3 hours to do the test. I may give you just about an hour and a half at most. An hour and a half at most. All right, let me get out of this because I don't want to mistakenly share that screen because I know you guys are very quick at your fingers. And we just snap it. Yeah, but as I said to you, hear me out, and let me just warn you off again. I want you to be diligent students. What I have written for you is not any of the questions that you will get for the mid-semester. But all I'm saying to you for the mid-semester, if you can understand this mid-semester that I've given you, you are good to go. Now, I recognize that you want me to do, Sash, you wanted me to go through something. Talk to me.
Yes, sir. Oh, by scroll up, sir. Oh, right there. Right?
Yeah.
Right? Oh, not
no,
there.
the bigger one, sir. Yes, sir.
All right. So what you basically do, sir, because that's what I'm reading. Okay. So you did x minus 1 times the numerator x4x plus 4h. And
Sir?
then you do put back the minus sign and 4x times x plus h minus 1. And you wrote back.
Sir, maybe we need to do one without the bag of letter them because the first time I did that, they confused me until I was able to link it to the numbers version of it.
Okay. All right, fair enough. Fair enough.
Sir, is it that you cross multiply, sir?
It's not really cross multiply, no. But let me show you what it is. And based on what Yanika said a while ago, let me show you what.
Sir, really gonna one next level.
Fancy equipment, sir.
Sir,
we are going to gloves up and use with that, yo.
Sir, gonna new level.
All right, let me just
behind the scenes.
You see, at times it prevents me from sweating on the tablet. So
sir.
No, it's when you move into online teaching, you have to make sure your students get what they're supposed to get. So I invested in it. It's a lot of money, but I invested in it. All right, let's go. So what Yannick is saying is, for example, you have 2/3. minus 1/4. Come on now.
You're writing, we're not seeing it.
You're not seeing it?
Yes, sir, I see it.
I'm seeing it.
Where? Oh, screen zoom in. Sorry.
All right, cool. And then now you're finding the LCM, and the LCM there is going to be 12. So this is what Yannick is saying. The LCM is 12. So here, look at what is happening. How many times can 3 go into 12? And it's a 4 times. And it's going to be 4 times 2 to give you this 8 here. Lambert, you don't see that at all.
Yeah.
You don't see that at all.
Sir, do it again, because I don't really see it neither.
Yeah, man. What I'm seeing is I'm seeing the facial expressions.
So,
you can do it on the next side of the page.
So it's
Yeah.
the denominator, sir, you used to work out that part?
Yeah, all right. I'm being asked to do it on the other, oopsie daisy, on the other side of the page. Not a problem.
And sir, is it that you just wrote back that part?
This is the find the HCM question.
After the part about finding the LCM, is it that you just wrote back the function right above where you did the working out?
Yeah.
Oh, because that was confusing me, sir.
Yeah, man. Let me just open. I just want to show you an example. I mean, I think you raised a good point.
I'm not seeing the screen, sir.
I know. I'm actually trying to open up, but my system is taking the usual while to come up. All right. So I'm going to create a new share now so that you can see what is happening. All right, you should be able to see it now. All right, so what I'm saying to you, 2/3 minus 1/5. The LCM here is going to be 15. LCM there is 15. And I'm asking myself, yes, please.
Onika made a suggestion that I think would help it look clearer. She made a suggestion in the chat to put 3 times 5 instead of 15.
Okay, I have no problem with that. I have no problem with that. That's fine.
Yes,
so
sir.
I'm multiplying the LCM, the denominators, in order to get my LCM there. Now I'm saying, how many times can 3 go into 5? I mean 15. There's a trick to this, and watch it. How many times can this go into this? It's going to be this time. And how many? Sorry, let me spotlight so you can see what I'm talking about, this and that. How many times can this go into this? Is going to always be this times. And how many times can this go into this? Will always be the opposite times. So 3 into 15 goes 5 times. And then I'm going to say 5 times 2 is 10. It's not a cross multiplication. And I don't want anybody to think of it like a cross multiplication. It's not a cross multiplication. All right? And then the operation that we're talking about is a subtraction. And then 5 into 15 goes 3 times. And 3 times this -1 is -3. So 10 minus 3 is going to be equal to 7. So this now becomes 7/15. It becomes 7/15. So that is my 7/15. Now, it's the same thing that I would have done with my algebraic expression. The only difference is that I'm in algebra. So what do you mean by you're in algebra? I'm using variables, x's, and numbers. All right? So let me create a new share just to show you, go back to what it is that we have been doing. So remember what I did, how many times, let me spotlight, how many times can this go into this? Is going to be this time, number of times. It's going to be x minus 1 times. So it's going to be x minus 1 times this up here. So how many times can this go into this? It's going to be this number of times. Or another way of looking at it is, how many times can this go into this? This and this are the same. So you cancel them out and you're left with the x minus 1. See here? The same x minus 1 up here. So it's this x minus 1 that you're now going to be multiplying by the numerator, just like I did, to give you this x minus 1 times the numerator. You're leaving out your middle sign here, and you're saying this, you're asking yourself the question again. How many times can x minus 1 go into x minus 1 times x plus h minus 1? Because this and this are the same, you cancel them out, and you're left with this. So it's going to be the x plus h minus 1 times my 4x. So you see here, it's my negative 4x times the x plus h minus 1. And all of this, I am no longer interested in this because I would have now condensed these two fractions into one single fraction, which was my aim. So having condensed those two fractions into one single fraction, I am now going to be taking out the single fraction that I have. See here, that's a single fraction in blue. And having done that, I recognize now that I have to now distribute this x minus 1 over this 4x plus 4h. X times 4x gives me 4x squared. X again times 4h gives me 4hx. This negative 1 times 4x gives me a negative 4x, and this negative 1 times a 4h gives me negative 4h. And similarly, I am leaving my middle sign out, and I'm saying 4x times x is 4x squared, 4x times h is 4hx, and 4x times negative 1 is going to be negative 4x. Then I'm going to remove these parentheses that I have here by saying negative 1 times 4x squared is a negative 4x squared. Negative 1 times a positive 4hx becomes a negative 4hx. And a negative 1 times a negative 4x is going to be a positive 4x. And of course, all of this will be written back right here. Remember, I have 1, 2, 3 terms. I must have the inverse of these terms over here so them can cancel out. What is the inverse of a number? It is the opposite of that number. The inverse of 3 is negative 3. All right. So because I have a negative 4x squared right here, so it means that I must have a positive 4x squared somewhere out here. So see it right here, so. And this negative 4hx, it means that I must have a positive 4hx somewhere else. See it right here, so. And this positive 4x, I must have a negative 4x. See, what is wrong? See it right here, so. So what is going to happen is that I am going to be canceling out these terms, and then going to be left with only this negative 4h. And this negative 4h is going to be right here, along with my denominator, because I have not changed that, and along with my reciprocal of my denominator, which is a 1 over h right here. At this point in time, I am now able to cancel out that h. I'm now able to cancel out that h. And in canceling out that h, this is what happens. Bam cancels bam. So this h cancels that h. So all I'm left with is negative 4 over x minus 1 times the x plus h minus 1. Now we are able to evaluate the limit because we would have removed the 1 over h. Having done that, I'm going to let h be equal to 0. I'm going to let h equal 0. And then when h is equal to 0, I'm going to substitute the 0 right here. So I'm going to have -4 over x minus 1 times x minus 1. And remember, x minus 1 times x minus 1 is the same thing as x minus 1 all squares. So my first principal differentiation is going to be -4 over my x minus 1 all squares. And that's it. That is it. That is the end of the class. That is it. If you have any questions, shoot, let me answer them now. On Tuesday of next week, all being well, I will answer whatever questions you may have. I'm going to send you the solution to the paper that the Mid Semsster, and we are going to be going through, and we are going to be working very hard. Now, hear me out. And hear me out well. Please to go through from start to finish of what it is that we would have done so that you are fully prepared for this paper on Thursday. We don't want a 50% and not 40%.
Sir, this is from unit 1 to 3, the paper.
Something like, yeah, something like so. Yeah, I think, yeah. I can double check, but I think this is it. I don't want any 40-something%. Now hear me out, students. When we're doing our mid-semester and our edit off pieces, we're going to try and maximize on those because we don't know what the final exam is going to look like. We don't know what the final exam is going to look like. And if we buck with toe, at least you don't have to bust up your face and can still pass the course. But when you struggle through the mid-semester and struggle through completing your edit off pieces and going to the exam and get a 50%, because the struggle right there, so chances are you come out with a D+. What I'm saying to you is always try to go into the exam with an A, because any card can play, and if any card plays that is not what it is that you want, at least you're still in a position to pass the course. I'm going to ask you to, you have 1 week. That's a whole lot of days. Sir, me have work and have family. Yeah. Me have work and family too and everything. So what you need to do is to study. Prepare yourself in such a way that you will first make yourself proud and make your teacher and the energies that he's putting into all of this very proud. I'm going to send you the recording as soon as it becomes available. And what I'm going to ask you to do is to go through again, look at the stuff. Now, I'll just use 2 minutes thereabout. What time is it? I'll use 2 minutes. I have 7 minutes.
Sir.
Say it again?
Scroll up while you're at it.
Okay, no problem. All the way up, or that's fine?
Up, sir. To the top of this question. No, all right.
Yeah, let me just do this. All right, hear me out now.
Yeah.
On Thursday, it's all those cameras, like the German camera that don't work. He's going to have a challenge because all the cameras will have to be turned on. And we are going to be, ideally, the microphones. Say it again, Papa?
Yes, the camera will be turned on for the exam.
Yeah, your camera needs to be on for the exam next Thursday.
Oh, camera needs to be turned off for the exam on Thursday.
It needs to be turned on Thursday.
Why, sir?
That makes sense. I'm not saying.
What's the reason for that, sir?
Sir wants to put it up on it.
I'm mad. That you be around.
Sir wants to was stressed by it.
Oh, absolutely. But your cameras will be on for next week. So those of you who have a challenge with your cameras, you have a week to go and sort it out, right, Jermaine? Your cameras will be on for next week.
Yes, that's just me already.
All right, that's good. So I'm happy that I don't tell you on Tuesday. So you're stressed Wednesday and then the exam is Thursday. So you have enough time to get to de-stress. All right, but
Ryan, we need some white lady for Thursday.
Remember the question I asked you?
Always have it.
Yeah, I will answer you.
Message me. WhatsApp.
Yeah, in WhatsApp. You can just send me a WhatsApp just to remind me, and I'll respond to you. Yeah, but students, yeah, so your camera is going to be on for next week. I am not worried about you. What I'm worried about is that some of you may not look at the recording. Some of you may not go through the handout that I'm giving you. Some of you will not go through the handouts that I've given you. Some of you will not put the level of work into the stuff. That's the only thing I'm concerned about. But if you fail to prepare to ... But I'm not worried. I think it's a good group of students that I have, and I think you are purpose driven. And I really don't, I really just want, when I mark those papers, I want them to say to me, Mr. Shan, why did everybody get 80 something %? And I can show them the paper and say, one go remark it yourself and tell me how much should I give them. All right? So that's what I want to happen. I really want to see all of you. I have 20 plus of you.
Effort, sir.
No, it's not pretty enough. We're going to tell you the challenge. Procrastination is a serious student problem. And I will tell you that I know I suffered from it. I know I have a test, and I wait until 2 days before, and then there's something that I don't know how to do, and I don't have enough time to understand it. And instead of going to the exam and getting 90%, I go in the exam and get 70%, because the thing that I don't know came back on the paper. So that's what I'm concerned about. All right. Go, Davio. Final question.
Sir, flow door reliable, sir. Sometimes I'm not saying it's going to happen. What would we do in case flow or JPS do something, sir?
And we can talk if that happens. We can talk if that happens. And remember now, guys, you see when it's when I say to you that the papers need to be on Tuesday. I won't do anything more tonight. On Tuesday, I will show you how it is that I expect you to add the stuff on to the platform. So when I say to you that your papers are now due, and I'll give you like 5 minutes, you're about to put your papers together, and I'll tell you what you need to do and so forth and so on to get it to me. I will then close the system out at that time, and any paper that I don't get will not be marked. All right. So I really want obedience.
Hold on, sir. I never catch that. What you say?
No, what I'm saying to you is that I will say to you, so when I say, just like in an exam, paper-based exam, when we say time is up, and you have to stop writing, when I say time up in the online medium, I expect you to stop writing. And then just like we have to take time to sit, to walk and collect the exam paper, I'll give you enough time to go and take the photographs, whatever. I'll tell you how to go about uploading the paper to the exam, to the platform, so that I can get the paper, so I can start marking. I know what is going to happen next week, Thursday. Next week, Thursday, I am not going to be able to sleep even if I try, and I'm going to want to mark those papers. Okay, so my light just dimmed a while ago. I think it's time for me to finish class. All right, if there are no other questions,
I'm writing out the thing because I want to have it for tomorrow.
I'm going to send this to you now.
Oh, but I want to write it.
Okay, go ahead and write.
So just to confirm again, based on what I heard, so the exam will be given the option to like use pen and paper, not Microsoft.
Oh, yeah, man. I'm gonna give you pen and paper. Yeah. So what we're gonna do is write it on paper. If you choose to write it in your notebook, it's not a problem. You're gonna write it on paper, and then when you finish writing, you're gonna take photographs of it, and then all those photographs you're going to be putting in a Microsoft Word document, and then you're going to upload that single Microsoft Word document file that will contain maybe about 4 or 5 photos in it. Then I am now going to be using my writing tablet to mark it and make comments. And at the end of it, when I do that, I'm going to send you back your marked paper so you can look through to see exactly what it is. A copy of your marked paper so you can see what has happened. And I will keep a copy of it.
So no PDF file, sir?
No who?
That's for Tuesday, sir?
I will show you that on Tuesday. I'll show you how to do all of that on Tuesday. Yeah. No PDF file. I'm going to tell you what does that mean. Whereas this is new, my computer is on the archaic side, and I have to be careful.
Okay,
I have to be careful how I talk to it, because this morning I was doing something on it and then it decided to show me a blue screen, and you are all computing students, so you know what the blue screen means. And I have to be saying the Our Father prayer over it and just, praying to God and opening one eye to see that everything is all right. But fortunately it came back up, so I was able to stream and to do what it is that I'm doing here on the system. So it's again, Papa, I need to update. Yeah, I know. I'm trying to update, but I mean, I'm going to be updating soon, but in the meantime, before the update gets here, I have to go with them there. So the PDF, actually, all of this is going to be it's all right, Peter. So the PDF is going to be problematic for now for me to access. So I prefer Microsoft Word. All right. I enjoyed class tonight, and I hope you did too. And I really hope that you guys have learned and have seen a missing. Oh, by the way, anybody got 30 out of 30?
No,
Yes, sir.
No, sir.
No,
If,
sir.
if you take off feel like -4, then no.
Sir, yes.
Charlie, you got 30 30?
No, Onika says she get 30 out of 30.
Right, Spark.
Oh,
Sir,
very, very good. Yes, I'm hearing you.
sir,
Go
you
ahead.
see, because I start I try out a big school maths thing and now write down all the little baby something them when I normally write down, I lose a 1-1 mark. But sir, you go get a paper with baby word. Come and not lose no mark like this.
You better believe it. You better believe
Sir,
it.
how many questions for the mid-semester?
It could be a similar setup to this one, I'm thinking.
You never see a seat already.
Huh?
You never see the paper already.
Sir, write the paper. Mid-semester. When I tell you, say, drink some Ryan rum, I write the paper already.
Hey, Kells, short. Yeah, cut my story short, Just cool, man. All right, yeah, the paper ready, man. Paper ready long time. The paper ready from June. June? Yeah, paper ready from June. It's so long me prepare for no from June.
Sir, just say CCCJ send the paper.
So we had to work on a paper from in June. So we worked on a paper
Anyway,
in
sir,
June and then yeah, man.
how much question was on this?
On what? On the actual
Sir,
mid-semester exam?
you said it's similar to this, sir.
Similar to this one. How many questions on this?
Yes, sir.
We got like part A, part B, part C, and we had like 2 questions in part A. You may get 2 questions and can give 3 questions and can give 4 questions. Part B, we had 1 question, they may give you 1 question or 2 questions. Part C had 2 questions, they may choose to give you, 1 fractional form to do first principles, or they may not choose to give you that. But all I'm saying to you, use what I gave you here as a guide, and you should be good to go.
Same 30 marks?
Sir, when are you gonna show us the one with the bracket question? With the four different, what's the name?
Talking the piecewise.
Piecewise, yeah.
Yeah. I can do that. I can do that on Tuesday. Just remind me before, so I can prepare the question, so I can do the question and have the solution. I find that when you see what happened today, when you are able to work ahead of me, we could spend some very quality time, good time to go through, as opposed to be waiting on you to do the question. So congratulations. I'm most congratulated for doing that for the most part. I know it's not everybody that can do it. Chemistry not in class today? Anyhow, I know most of you didn't, some of you rather, would not have completed all the questions, and you may have done it in class tonight, or maybe just don't say nothing. But for the most part, I really am appreciative of the class. You guys give me the energy that at 4 minutes past 10 o'clock, I am still ready to go, but I'm going to stop here now. I really thank you for coming out, and I really hope that on Thursday next week, you still have enough time to prepare. On Thursday next week, you guys will be fully ready for your exam. All right?
Okay, sir.
Sir,
I can get a work like how you're still ready to go, sir.
What happened?
Eddie cuts off, sir. You still not take out them something.
Oh, all right. Yes, and I trust me, I got distracted trying to do this registration. And I can tell you, I really got distracted in the registration. There are some You remember the results came out last week, not last week, week before last Friday. So we're doing that level of registration for those students, and it took up quite. I was in so many meetings today, but anyhow, I am going to. You'll be proud of me by tomorrow. It will be done. You'll be very, very proud of me. Yeah, man. I'll do it. I'll get it done for you.
Sir.
Anyhow, yes, please go ahead.
May I go beg you a favor?
Uh-uh.
I'm asking for me and for anybody else who needs it, just to repost your YouTube channel in the group for me, please.
No problem. No problem.
Thank you.
No problem.
All right, you can go sleep now and take off the Sunday best.
No, I'm gonna be with the Edicus off. Him can take off the Sunday best.
Oh, you can take off the Sunday best and deal with Edicus off. Okay.
Elvita,
Yeah.
if you look in the group, when you select the top part to go to mute info, mute notification or so, in the description part, the link is right there.
All right, thanks.
Yeah.
All right. Ooh, thank you much. Have a good night. Sleep tight. Don't let the bed bugs bite. Study hard. You'll be fine. Later.
Good night, sir.
Night, sir. Thank you.
Night, sir.
Night, sir.
Good night, honey. Take care, guys.
Oh, good.